everyone! You are listening to Through Time and Clades. My name is Joan,
And I'm Albert.
and today we're doing something a little bit different for a change. We have an interview with a well regarded paleo YouTuber, paleontologist, um, and we're also going to be doing our nature news for July 2023, whom our friend is going to join us for. So we've kind of taken to calling this an internews episode because we're kind of mashing two of them together. um, but before we jump into that, Albert, how you been doing?
Oh, I've been doing not bad, I would say. I guess I don't have much that's worth reporting, but I did kind of wrap up my part in a large research project that I've been working on for a long time. I've kind of alluded to it in the past. So now that is currently in my co author's hands, and so they'll give some feedback on it before it comes back to me, and I will have to change things according to what they think. But in the meantime, yes, I'm very glad to be able to have gotten that, at least temporarily, off my hands for the time being. And so I'm kind of thinking about the next projects to do, but also taking it a little bit easier than usual because, that one took a lot of work. So eventually, when that goes public, hopefully, um, I can talk about it more. But I think that's probably my biggest thing. How about you?
Yeah, not too much to report on my end as well. I mean, I've certainly been working on things for the show, slowly preparing the third update special to Humanity a Prologue, which is moving along at a bit of a snail's pace, but I hope to have it at least completed by the end of the month, which will coincide with our upcoming 3-year anniversary of Through Time and
Hmm.
Clades. Which, oh my gosh, where did the time go? Um, I think one of the most exciting things that's happened recently is I got to introduce my mom to Princess Mononoke. Um, I took her to the Ghibli Fest showing last weekend, and she adored it. She thought it was amazing,
Hmm.
and I mean, it's an amazing film. So I'm glad she was able to kind of get the same experience as I had.
Hmm.
And she's had it on her mind for days now, which is yeah, that sounds about right for first timers checking it out. Um, just amazing stuff. Um, but also, like probably the most exciting thing that we've been able to do is prepare this interview for us today. Everyone, we hope to introduce, if you haven't known about them already, our interviewer, Ade Ben-Sal. Ade, welcome to Through Time and Clades.
Hello, hello. Thank you for having me.
Hello.
Oh, so what we're going to be doing today, again, this is kind of a hybrid model for a show. Ade is going to join us in presenting our nature news for our July 2023 stories. But before we do that, we're going to do a small interview with him just to kind of learn about his life and work. So let's jump to the next slide. And, well, Ade, tell us, who are you and what do you do?
Right, so that's a big question. Yeah, my name is Ade. I'm from New Haven, Connecticut, and I guess the first thing most people might know me for is my YouTube channel, Adasaur, which I started, I think, in 2020 now. Yeah, actually, I think a couple months before or after you guys did,
Huh.
actually. So we've kind of grown in parallel. But yeah, I started during the pandemic, and the funny part about it is that I was looking at the paleo YouTube space, and I was just sort of thinking like, I wonder if I could add anything to this. And
Hmm.
I just thought, maybe Triassic reptiles or something, because I liked the Triassic period, still do.
Hmm.
I don't know why I'm saying that like it's a past tense thing, but um, yeah, I saw that sort of gap that didn't quite exist at the time. And I was like, let me try my hand at making a series or something. But it'll be something I'll get around to eventually, maybe. And like I was in school at the time and um, trying to do other things, finishing college and things like that. But then the pandemic hit and everything shut down, and simultaneously, um, my my job at the Yale Peabody Museum as a fossil curator was also closed, both because of the pandemic, but also because the museum was actually starting its renovation process. If you haven't seen the news, actually, they are approaching the end of that process now, so they are almost done. I think they should be opening sometime early next year, so I'm really looking forward to that. But but yeah, so I have found myself with a lot of sudden free time, and I was fortunate enough to be in a circumstance where I could sort of dedicate a lot of that newly found free time to um, some sort of creative venture to sort of keep myself academic in some way. And yeah, that was the start of the channel and the series. And so since then, it's been ticking along. Nowhere near as I guess productive, if you will, as some other channels have been. Um, but I feel like I've gotten a lot better in terms of the videos I've made. Um, I'll let the audience be the judge of that for anyone who's watched them at this point. Yeah, like I mentioned, I used to work at the Peabody Museum. The picture to the left is me measuring some Allosaurus teeth for a study that I um, sort of ended up helping with. Although, I mean, as a museum curator, you kind of end up doing a lot of sort of helping with a lot of different projects. But this one I actually got to like do some actual work for, as opposed to like just grabbing things from shelves and stuff like that. Um, so yeah, I did that for about, I want to say about 5 years, with a maybe like a year gap in between. Once I started my undergrad, and fingers crossed, get to go back in there once everything's reopened. So yeah, paleo YouTuber, uh, former fossil curator, and I guess shifting over to the right side of the slide, um, if you see me, or I guess know my proper name, um, in sort of the media space, you might know me from the Black Birders Week circle. Um, so in case you're unfamiliar, Black AF in STEM was this group that was started by just a bunch of um, mostly younger ornithologists and bird watchers and nature enthusiasts in general, all of whom happened to be black. Um, and it was a group chat and people who just sort of knew each other from either from an event they met at, or maybe some of them went to school together or something. And then in 2020, 2020 was also not just the year of the pandemic, but of course a sort of racial reckoning year, if you will, at least in the United States. And one of those incidents was the Christian Cooper situation in Central Park, um, which I won't go over that story too much because it's been, told to death at this point. Um, but yeah, they saw that incident and they said we need to do something about this and show that we've had these sort of experiences. This isn't a one-off thing, and ultimately just sort of normalize the presence of Black people in the sciences in general, and in the fields, literally and figuratively. And so I was not part of that group, but I heard about it. I wasn't even on Twitter at this point, but I'd heard about it through, I don't remember how I actually heard about it, come to think of it. But I just heard rumblings that there was a community of Black scientists out there, and going to an Ivy League school, you don't necessarily see a lot of Black folks in the natural sciences specifically, let alone STEM in general. But so that was an interesting sort of draw to me, for me at least. And so ultimately I hopped on Twitter in, I think, early 2021 and just happened to stumble onto the Discord the group had at the time. And since then I've been sort of involved in one way or another in the subsequent Black Birders Week events that they've held. And it's been really, really, I can't really put into words, actually. It's hard to describe like how much I've gained from it, both in terms of like on a personal level and in some ways professionally as well. I've gotten to write for various bird-related outlets. I've gotten to do stuff with BirdNote. I've gotten to do stuff with the Cornell Lab of Ornithology or their publications. Um, and it's just very interesting considering that as far as birds are concerned, I wasn't really a bird watcher in any real way until about a year and a half ago. Um, and so now, people will see this, might see this public persona and think, oh, he's been into birds for a long time. I'm just like, not really. So like, how do I get into a position where I'm sitting on an island off the coast of Maine with a tern sitting on my head? Um, it's just a crazy whirlwind tour of the last in the last year and a half. So yeah, really grateful to the people who've been offering all the opportunities and the people who made these opportunities able to happen. And sort of my ultimate goal at this point is to sort of merge all these things together and bring the sort of the paleo side and now the bird side and the science outreach side with the social justice side that comes with that, and sort of, I don't know, somehow merge all of it into one cohesive sort of package. Exactly how that'll look, we're still figuring it out, but that's sort of the spiel of me.
Well, it's really wonderful to hear.
Mm-hmm.
It is interesting to think about kind of the parallels between our two channels. I think about how Through Time and Clades essentially had its start when we contributed to Dino Nerds for Black Lives.
Oh yeah.
If you
Oh
recall
yeah,
that,
yeah.
because
Hmm.
we had a radio show on Alb's side, Instants and Reflections, that I had come into about halfway through its run, because your old guest had gone to greener pastures, and I had known you for some time by then, and I wanted to hop in, and so we had done that, and then of course you had graduated, and that kind of fell by the wayside. Um, and then when Meg and all of her friends were announcing Dino Nerds for Black Lives to help contribute to humanitarian causes, um, we wanted to provide our support and join in too. So we kind of, yeah, we did kind of revive Instants and Reflections for a little bit, and we had almost kind of forgotten how good it felt to work together and share these discoveries with people who might not be aware of them. And so that just kind of led us into creating Through Time and Clades, incidentally during the pandemic time, because I was laid off of work and um, among other things, and I wanted to help keep my interests in natural history alive. And I mean, I've been very grateful ever since. I get to meet all kinds of wonderful people and read widely in the scientific literature. Um, that's exciting to hear from you. So I guess kind of reaching back a little bit into the past,
Hmm.
what made you decide, or what inspired you to pursue paleontology?
Well, I've always had, or I'll put it this way. I've always been that kid who started watching Animal Planet and Discovery Channel at like
Mm.
2, 3 years old and just never stopped watching it until
Yeah.
it went off the wayside at least. But
Mm.
story for a different day. Um, but yeah, I've always been into nature and biology, and um, I credit first and foremost my parents for that because they were the ones sitting me in front of the TV watching the stuff and buying me the books and all the toys. And it was a pack of dinosaur toys I specifically remember. It was, well, no, it came in two different things happened first. First, it was a set of these three large dinosaur toys, and I can't remember. I have not been able to find any of them through all my lookings online. But if anyone knows, there was a green Brachiosaurus with like purple stripes running down its back, and then another one was a Triceratops that was like a green, like a dark green hue, and then like a purple hue on its back, and then its frill was also kind of purple. And I distinctly remember somehow in playing with it, I broke one of its horns off. So it looked like the Triceratops or the Torosaurus, I guess, from Walking with
Oh
Dinosaurs.
yeah.
Yeah.
Um, so I just thought that was a funny parallel. And then I forget what the third toy was. I think it was a Parasaurolophus, but I forget what the color scheme for that one was. But they were all like maybe a foot long or so, and they were pretty densely built. Um, so it was those three were my first like starter pack of like dinosaur toys, and then my dad at some point bought me this like it was like a box of maybe 25 little like smaller ones, like maybe an inch or two long, and they were more flexible. They weren't as like stiff as other dinosaur toys were. And I've
Mm.
seen little versions of them around online, and I can't pinpoint like if they come from any particular collection or not, because I obviously I didn't keep the packaging. Um, but yeah, it started with that, and then just from there, the big thing was just watching all the documentaries that were coming out at the time. So to age myself a little bit, I'm one of those people who's like the very tail end of being a millennial, but also little too old to be what they call them, I guess, Gen Xers or Gen
Mm.
Zers now.
Yeah.
So like I know what like a floppy disk is, but I
Mm.
never actually used one. So I'm in that sort of in between period. So like late 90s, Walking with Dinosaurs had just come out. I was too young for that to remember that one premiering, but I do remember distinctly watching When Dinosaurs Roamed America, and that was I think 2001.
Mhm.
And we recorded that on VHS, or my mom recorded it on VHS for me. Um, and pretty early on, I figured out how to record things on VCRs. So
Mm.
by the time like Dinosaur Planet came around in 2003, like I was recording that myself, and just rewatching all these tapes over and over. So like every piece of Paleo media, basically from like pretty much throughout the 2000s up until maybe 2008, 2009ish. I guess the sort of the dark period, if you will.
Mm.
um, that was sort of my foundation, and then um, it sort of dipped off a little bit, and then coming back into it in like when I was in high school, so like early 2010s, I discovered um, the internet realm of paleontology, and more specifically, DeviantArt. Funny enough,
Yeah. Mm.
Yeah.
so I was looking at like Julio Lacerda's early work,
Yeah.
and who else? Who else? There were some other really big ones that were influential for me. Mijiao Diallo's work was up there at the time.
Mm.
Um, Julius Ciotni, I believe that's how you pronounce his name. If I'm not, if that's incorrect, please, my apologies. But yeah, his work as well. Um, Dave Krentz. Somehow I discovered. I don't know if he had a DeviantArt, but somehow I found his work or
Mm.
his 2D sketches as well. So just like online DeviantArt Paleosphere sort of revitalized my interest in dinosaurs, because I was like, oh, we've learned more things since I was a kid. Cool, and let me get caught up. Um, and then Saurian was another big one, because
Mm.
then that was that whole project, still is that whole project, chugging along as it is. But like especially when it was in its I guess at its peak of popularity, I was very much in that like sphere of excitement about having a game like that,
Yeah.
and also just like all the work that it was presenting to the general public. I just thought, wow, we really do know a lot about all this sort of stuff. Let me like pursue it even further. And so ultimately, when I started going to college at Yale, actually, I was majoring or aiming to major at least in ecology and evolutionary biology. Um, and so things have happened since then. I haven't finished there. I've left Yale, but transferring to different schools and doing other things still related to paleontology and science outreach. Um, I don't know. I just think it's it's really fascinating, like just to think about how everything you see around you like has an ancestor,
Mm.
right? And ultimately, if you go back far enough, we're all family in one way or another. And I just think that's kind of like it's a very almost spiritual thing
Yeah.
Mhm.
in a sense.
Totally.
Just like the interconnectedness of like life in general, and it's just always been a fascinating concept for me. So paleontology specifically is like just one vein of that I recognize and appreciate, and happens to be the one I like the most.
Mm.
So So there's that. Um, yeah, I'll let you go on to the next question. I was going to say something else, but don't want to keep rambling too much.
Oh, it's all good. I guess in that case, obviously dinosaurs are a huge draw for a lot of us into paleontology. But are there any dinosaurs or just prehistoric organisms or groups of organisms in particular that interest you the most?
Um, I've always bounced between certain ones. So, especially when I started my YouTube channel, because I guess the scope of my channel has always sort of been whatever I feel like talking about that I feel that I can contribute something to the conversation on, if you will. So I don't necessarily like repeating things other people have said as
Hmm.
much. And so that sort of led me down these corners of what are these creatures that are sort of underrepresented in one way or another. Um, so some groups that I've found in that sort of vein, definitely the Gigatitan and the Titanopterans in general. So these are these giant. Well, I say giant. I mean, they were big bugs. They weren't as big as like necessarily carboniferous bugs, but they were still like unnervingly large cricket mantis chimera type things um, that lived during the Triassic period, but also had they survived the Great Dying actually, and they were only got bigger from the Carboniferous onward. Funnily
Hmm.
enough,
Yeah.
um, so those are one of my favorites now. My first video was actually on Gigatitan specifically, and um, I like to follow the science of things as once I've posted a video, see how things have updated since then.
Hmm.
And there are just a lot more that's actually come out about Titanopterans in the past 2 or 3 years since that original video was made. So last year I actually did an update video, updating all the paleobiology and stuff like that. So they're definitely one of my favorite groups. Um, Another one that I'm particularly close to in general now, I think just through my field work experiences at this point. I guess you call them uh, not study species, or I guess yeah, study species if you're a practicing biologist, if you will. Um, yeah, my two sort of study groups at this point are definitely terns,
Hmm.
um, and that's a story that comes out of my associations and work with Black Birders Week. Um, I got the chance to go out to Maine to do some work with Project Puffin. So it's this really cool conservation project that started, or actually conservation and restoration project actually that started in I want to say the 70s, I think, or late 60s, early 70s, with Atlantic puffins and trying to bring back the population that used to live in Maine before they were all killed off in the late 1800s.
Mhm.
And so a man named Steve Kress, who was I think he was a like a counselor or something at the Audubon Society like Hog Island camp up in Maine. He found out that puffins used to live there, said, "Oh, this is a shame. Let's bring them back." So he took some baby puffin chicks from some neighboring Canadian islands, brought them to uh, one of these islands off the coast of Maine proper, and after about 5 or 6 years, they actually came back and they started breeding. And so they expanded the project to include all these other seabirds because it wasn't just the puffins that left. All the other seabirds had either been killed off or chased off, or they just left once their neighbor species were gone. Um, so if you bring one back, you have to bring back essentially the entire ecosystem, and they've managed to do that pretty successfully. So now these islands, like just off the coast of Portland and whatnot, um,
Mhm.
like the one that I was on, this tiny 5 acre rock, basically out in the middle, almost the middle of the ocean, um, with like 6,000 turns on it, and they don't want you being there, but you have to be there to sort of monitor them and make sure everything's copacetic essentially. And so yeah, so I spent about 2 weeks out there, and I definitely got in some way. kind of attached to them. Not necessarily like an emotional attachment, but just like I don't know, my first proper fieldwork experience. I'm out here with these birds. It was my first time actually like camping too, technically.
Mm.
So that was a whole, yeah, that's a whole interesting experience. And then actually, funnily enough, last week I happened to be down at my local pier, um, and saw some common terns flying around, and that was the first time I'd seen them outside of Maine. Um, so the sounds, I was like, oh, I know these sounds. I know these sounds. What are these? My former neighbors are back. Um, so yeah, Titanopterans, common terns, and then the last sort of, I guess, to make up the trio are Adasaurs.
uh,
And I say that partly because I just always thought they were interesting, um, but particularly because last summer I actually got to do my first real paleontology field work too, out in Arizona, um, with a professor from the school I'm currently at, um, who, if you are familiar with Postosuchus, he was actually, I guess he's technically one of the world experts on Postosuchus.
mm.
Um, he published the paper, and did, or I guess he did the study and published the paper that heavily revised Postosuchus taxonomy, or not taxonomy, excuse me, Postosuchus anatomy. So like the reason we think Postosuchus is bipedal is because of his work now. Um, so I was out with him at this dig site that he um, has been going to for about over a decade now with his longtime friend, and I think they went to grad school together too. And I'm suddenly blanking on both of their names, but if um, you've seen any like pencil drawn illustration of pretty much any southwestern Triassic reptile from like the Chinle Formation or any of the other southwestern Triassic formations, you've seen his work, because he's a paleo artist as well. Martz, that's his name.
Oh yeah.
Jeff Martz. Yeah, Jeff Martz and my professor, Dr. Weinbaum. So yeah, Dr. Weinbaum, excuse me, Dr. Weinbaum is the one um, who's based here in Connecticut, and the other gentleman is based out of Texas. So the two of them, they kind of come together every summer to go to Arizona at this dig site. And so last summer I got to go out with them, to their dig site. We found some Adasaur osteoderms. I managed to uncover almost a complete one actually without breaking it, which I was genuinely surprised with. And I'll tell you what, I certainly gained a lot of appreciation for any paleontologist who does field work, because you are out there like in the elements for a long time, picking away. It's not like it's not like the how you might imagine with like a pickaxe or like a drill or something. Like that happens sometimes, but you really want to go out and go at it with, these tiny dental tools, because you don't want to break anything. Um, so you're laying on your, laying on your back or laying on your side. Usually this is during summertime, so you're in hot weather, exposed, and just picking away at this rock for like 8 hours a day up to, for weeks, just to pull out something maybe the size of your hand, and
Yeah.
never mind something that's like a titanosaur femur or something. Um, but it was a great experience, and definitely something I want to do more of and do again. And I'd love to return to that site and see if I can get more Adasaur fossils or anything else from the environment. So yeah, in a very roundabout way, Titanopterans, terns, and Idosaurs.
That's awesome. That's a good group.
Yeah.
Because that actually is a pretty good jumping off point. Because since you have field and lab experience, what are sort of your wider experiences in paleontology have been like?
Um, Interesting question, because I think yeah, most of my like actual work in paleo or in the paleo field has been in museums really, in the Peabody specifically, very behind the scenes, and it's a lot more, I guess, there's a lot more organization than you might think. Um, at least if you're, unfamiliar with it from the outset, which I certainly was. Um, so like my day-to-day job when I was there, I essentially called myself a fossil librarian because that's kind of what
Mhm.
you're doing.
Right.
Yeah.
So you're in the collections, you're making sure everything's cataloged, making sure everything's updated, and you're just sort of, whenever a researcher wants to either borrow something or have something sent to them or come in to see something, you got to make sure it's there, make sure it hasn't been borrowed by somebody else. If it has been borrowed by somebody else, you have to see where they took it or um, where they left it, because sometimes like leave it in the wrong spot when they return it.
Mhm.
Um, Maybe the person died while they had it out, so it might still be it might still be at their other institution like
Right.
2 decades later. Um, so you're chasing down a lot of records, if you're not chasing down and trying to cross-reference all these individual like specimen numbers. And I think one of the things that a lot of people don't appreciate about paleontology is how the vast majority of fossils are very small
Mhm.
and fairly nondescript if you don't know what you're looking at. So I spent a lot of time in like the mammal rooms in the Peabody looking at little teeth and just making sure all the teeth were there. And then dealing with all the sort of outdated taxonomy and
Mhm.
whatnot.
Oh yeah.
Um, yeah, because a lot of stuff hasn't been updated since, let's say the 70s to give it some grace. I think that the thing that typified that sort of experience for me was actually the there was about a week and a half period where I was asked to reorganize the hadrosaur cabinets in the Peabody's collections and reorganize them by taxonomy and also, well, not just taxonomy, but also they're specifically supposed to be excuse me, by formation and then in chronological order. Um, so you had like, it was mostly like mid late Cretaceous, like Bear Paw Shale down to like Hell Creek, basically. And so that involved, once I saw everything was labeled Trachodon, um, which for those who don't know is this outdated, essentially wastebasket uh, name that just every type of duck-billed dinosaur was thrown into, um, pretty haphazardly. And a lot of this was by Othniel Charles Marsh, O.C. Marsh himself, because he was at the Peabody for a long time. And a lot of the dinosaur specimens were collected either under his watch or by him or in association with, his work or whatever. And so he was involved in, the Bone Wars. And so they were just naming everything as quickly as they could and destroying each other's work and that whole saga. And so over a century later, I'm sitting here having to deal with his mess, essentially,
Mhm.
um, and reorganize all these cabinets and rename everything. And unfortunately for me, um, hadrosaur fossils are not small.
Right.
So definitely got a lot of work, a lot of aerobics, a lot of weightlifting work there. Climbing up on a ladder with like a fossil that weighs 40 pounds. It's always fun, always a fun time. Um, yeah, there's that sort of day-to-day work, and then you have the researchers who come in. So I've gotten to, meet various people just, you know, as they come through the museum. So like I've met, um, I believe Shu Xing came at one time.
Hmm.
I might have actually missed him that day, but I set up some stuff for him, like the day before he arrived. Um, was another person. Scanella, he came
Mhm.
through. I spoke with him for about a week. He was coming to do some work on the Peabody's Torosaurus. Um, and then there's some other names, who I'm sure if I look at like the publication lists and check it with the records, I'll be like, oh, I remember that person. Um, so yeah, you get a, depending on where you're based at, of course, you'll see some people, you'll run into some folks, and you can, if you have the right, um, if you have the right approach, you can always pester them with questions politely. So yeah, I got to hear some interesting opinions and takes from various paleontologists on certain things. And actually, the person I was working under at the time, who I think he's still there actually, Daniel Brinkman. Um, he, for anybody who's in the current paleosphere, is kind of one of the people who started the raptors didn't hunt in packs
Oh yeah.
pushback idea. So that was one of the things he pointed out to me when he first led me through the tours, was the fossils that he used to base that argument off of, which includes a broken off Deinonychus toe claw, which is embedded in the tail of another Deinonychus. So yeah, and it's always interesting to see that sort of stuff. And I think he was actually a student of Bakker, or not a student of Bakker, but he definitely worked with Bakker at some point, because they were around at roughly the same time when he was getting his start. Bakker was, I think, coming through or just leaving, but they were both, I think, being mentored by the discoverer of Deinonychus, whose name I'm suddenly also blanking on.
John Ostrom.
Yes, Ostrom, right. So yeah, you actually, that's another interesting thing about it. You sort of end up being, if you're in it long enough, you kind of end up becoming part of, I guess, sort of an almost paleontological mentor-student legacy sort of thing.
Yeah.
Yeah.
So in some way, I'm I think 1-2 degrees of separation from Ostrom, and by way of that, the communications he had with Michael Crichton and the Jurassic Park people, which is not a movie I've actually. I'm gonna lose my dino card for this one, but I didn't actually watch Jurassic Park until I want to say I was about 20, just before I started college. So it was always a movie that I just sort of, I knew about it obviously, but it was always on the purview of things. I was never really interested in the theme park aspect of it. But different story for a different day, I guess. But yeah, that's sort of life in the museum, at least. And then beyond that, it's mostly just been sort of the online paleosphere and just sort of seeing people interact, and you see all the takes, and you see the phases, and what are people mad about now, what are people interested in now. And I guess as someone who's formally at least sort of shifted into a degree that involves education, biology education is sort of my actual degree focus at this point. It's very interesting to think about outreach and how science is communicated, right? And so you're thinking about media representation all the time of your study subject, and looking critically at both the popular media, both the sort of educational stuff, but also the stuff that isn't meant to be educational but still has a large sway on people's opinions on things, and maybe even their knowledge base, and just sort of figuring out how to navigate all of that. There was a brief period, actually returning to museum, right before the pandemic, where I was doing tours in the collections at the Peabody, and I had a group of kids who were asking me, or no, well, they were asking me questions, and they were comparing, the fossils they were looking at to the Jurassic World creatures, because these are kids who are growing up with Jurassic World, not Jurassic Park. So I pointed them to Deinonychus, because there was, I don't think it was a complete replica, but there's a skull piece in there, and there's a foot there, and someone asked, "Is that blue?" And I said, "Yeah,
Oh,
yeah, that's Blue, the quote unquote Velociraptor from Jurassic Park or Jurassic World. Yeah, this is what she's supposed to be based off." And she said something like, "Wait, why is she so small?" And I said, "Oh, because the movies made them look a lot bigger than they should have been."
Mm.
And and then I really ruined their day when I showed them like a full reconstruction of of a Deinonychus with the feathers and all, and I put it, the size comparison next to a human. And then what really got them was when I showed them, because I had a slide prepared and everything for this. I showed them um, a Velociraptor to scale next to that because the Peabody doesn't have any Velociraptor stuff as far as I know.
Mm.
So I just had to use images for it, and they were thoroughly disappointed. And I couldn't. The funny part is I couldn't tell if they were disappointed in the movie or if they were disappointed um, in like the actual animal not living up to the movie's expectations that they presented. And that was, I thought, was an interesting dichotomy because some of them were like, "Oh, the movie's lying to us," and
Mm.
then others, most of them actually had that sort of reaction. Not as many had the science is ruining dinosaurs reaction that a lot of people, at least online, seem to have. But I think that might come partly from just like, this is just me spitballing now. I feel a lot of that comes from a more nostalgic induced take on dinosaurs from older people who are feeling some sort of way about how things are shifting, um, and how I guess science in general is in many ways not reflecting the view of the world that they had.
Mm.
And this extends beyond just dinosaurs. This applies to gender equity, racial equity,
Mm.
climate change if you want to get on that boat as well. um, it's a very interesting just wave of things that are all they're all related and they're all connected. I don't know if a lot of people explicitly see those connections, and but that's just something. I mean, I at least have always noticed. Maybe I don't know if it's necessarily because I'm black and I'm looking at things from a different angle than maybe the average sort of white American might be viewing things. But I don't know, I just think it's a very interesting pattern that comes about, and so it's always interesting to see people saying, keep the politics out of paleo. It's like, well, they're involved. They're very much tied together. That's the thing.
Right.
You're not going to have one without the other, unfortunately. But also fortunately, because mini soapbox moment. But there's this moment I like to recall um, from a virtual talk I was at about, I want to say about a year and a half, 2 years ago,
Mm.
um, where it was just scientists. This was on a Zoom call from like the global south, so to speak.
ooh.
And there was a gentleman from South Africa, a black South African gentleman, who's a geologist and a lecturer, and he teaches a paleontology course. And what he said was, um, and I will definitely like add this as a link so you guys can link to that
Mm.
portion of the speech. But what he said was essentially, um, like, what do we do in science and like doing statistical analyses? We want to eliminate bias, right? And so you're constantly supposed to be doing things that challenge those assumptions that you've had and do it in a way that eliminates the biases you might be coming with
Mm.
based on the data that you're using, whatever. And part of how you ensure that you're getting a diverse data set is having diverse scientists. And um, by excluding and keeping out people from historically marginalized backgrounds um, who want to get into sciences, you're doing a disservice to your field. Like it's I think the word he used was an existential crisis. Like
Mm.
science at this point is at a point of an existential crisis
Mm.
because so many institutions that practice it, um, they're blinding themselves and their results because of these institutional biases that exist in this can be through hiring practices and who they have doing the work and who they do and don't promote in terms of the personalities in the fields and who's big in those fields. Um, and I guess like to tie it back around to like the birds side of things and sort of like living conservation, or I guess conservation of extant animals, I should say. Um, when it comes to like bird watching and stuff, and this is not at all something that I work on, but there are some folks from the Black Birders Week crew um, who do like geospatial data analytics based on like who's watching birds in what neighborhoods.
Mm.
And there's this huge issue right now with, where is the data being collected from and who's collecting the data and submitting it to eBird. Because, a lot of this like sort of widespread um, bird watching data is done through like, participatory science or citizen science, if you will. And if you don't have, a lot of people from like more urban neighborhoods, for example, a lot of whom in the United States at least tend to be either from poorer backgrounds and or Black, Latino, indigenous um, uh, ethnic backgrounds. Um, if people aren't going to those areas and seeing, what the nature is like around there, in the various green spaces and whatnot, then you're not going to have money ultimately going to preserve those green spaces, and ultimately that leads to a lower quality of life for the people living there, as well as the animals that might be living there. And the funny part about it is that a lot of our major cities, at least in the U.S., are based on like literally they were built around these like prime sort of habitat spots that a lot of birds and other animals will migrate to as stopover sites, among other things. So you're missing a whole bunch of data because of essentially the things like redlining and the historical policies that have been going on um, in the United States within just the past few decades, not even going back as far as, the pre-antebellum period. Um, but yeah, so people are highlighting these issues in data collection and whatnot, and how it paints an incomplete picture of bird distribution, other, plant distribution, et cetera, et cetera. And, ultimately, where does that funding go to protect all these things? It goes to certain locations, um, many of which are primarily upper class, primarily white folks.
Mhm.
Um, and, it just sort of continually reinforces these patterns that have been going on since the inception of the country. Um, and so, sort of soapbox moment, bringing that back to what the South African paleontologist was saying, having all of these different, um, ensuring, I should say, that all these different people are here actively contributing to the science and being welcomed into it. Um, it's not just something you do just to say, oh, we're diverse, look at us, we have the people here, blah, blah, blah. Like, no, you're getting real tangible benefits out of it that everyone should want, to benefit from. So,
Yeah.
it can be conservation, it can be paleontology, it can be any other earth science, climate change related, especially. It's because it's ultimately going to affect all of us at the end of the day. So you might as well, rally all the troops, so to speak. Um, but yeah, it's that's my whole spiel on that. But just like, I don't know, it's always interesting to see how everything relates, and just it's always fun to be able to say that these are connections that are happening that have happened and need to happen.
Mhm.
Um, and so yeah, that's sort of how I've been trying to reapproach my being in paleontology and my being in um, whatever natural science space I happen to find myself in at that point, be it in a lab, in the field, or most importantly, I guess, doing actual sort of outreach and education work. Um, because ultimately it kind of does start with who you see presenting the science.
Hmm.
You know,
Mm.
if they're not being welcoming, on top of that, then at least if you see that person there, it might at least make you think, oh, I can be there too,
Right.
and then hopefully it blossoms from there.
Yeah, I mean, I couldn't agree more. I've seen similar discussions in anthropology. Certainly,
Mm.
um, the need for greater um, collaboration and input, and just listening to the voices of people who have historically been marginalized by that field. Certainly, in more ways than one. Um, it was interesting to hear about your experiences at the Peabody. I know you had mentioned that they're wrapping up renovations soon, aren't they?
Yeah, yeah. 'Cause I mean, I don't drive, but like I go past it all the time. And it's very interesting to see just the updates from both outside and also inside.
Mm.
By inside, I mean like media releases and things like that. I've been
Mm.
given some hints as to what's being put up in there, but I haven't seen all that much yet. So I'm very much looking forward to it. I've heard there's some what are they? Not. I think it's Blue Rhino
Yeah, Blue Rhino.
is the model making company. Yeah, they've been
Yeah,
commissioned to do some stuff for them. And I think they actually released an image of I think Gastornis actually.
Hmm.
yeah.
So they've got a life-size Gastornis replica.
Hmm.
There's like two or three other ones that I know have been commissioned. Um, the Brontosaurus, like the original Brontosaurus, apparently,
Mm.
um, that's been remounted in a more up to date and I guess more lifelike posture now. Um, which is always interesting to see because I remember actually being at the being at the museum in 2015 for I guess the official renaming ceremony
Mm.
Oh,
because this is
yeah.
when Brontosaurus as a name sort of came back in that from that 2015 study, and so the Peabody had has the original sort of Brontosaurus holotype at least, or at least the mount. I don't know how many of those bones are replicas versus the actual fossil material, but they have the first one, whatever it is, and they took the head off. Or no, the beheading ceremony was a different one. the the renaming ceremony was in 2015, and they just changed the plaque to say Brontosaurus again, as opposed to Apatosaurus. 2019 was the beheading ceremony. Yes, they called it that. Um, when they were dismounting everything, and that was sort of the symbolic. We're taking this down. We're going to shut everything down in like a month or two.
Mm.
And this was literally like early December. This happened early December 2019. So yeah, very much looking forward to seeing the new space and how much of the sort of initial architectural plans I remember being shown actually, were able to be followed through on. Um, they kept the Age of Reptiles mural,
Mm.
which, you know, as much because the thing about that, like my personal relationship with that is like, so I'd gone to the Peabody a couple times, like a decent number of times, I guess, when I was a kid, but there was a big gap between like the last time I really went there as a kid and then when I started going there to work there. And so I didn't have like that sort of, I guess, like up close and personal familiarity with all the fossils that were on display. But we did have that mural, or at least a section of that mural, um, for a long time up on the harbor where you drive into the city. It was on like a water tank or an oil tank or something. Um, until I want to say like 2015, 2016, sometime in the middle of the last decade, um, where they removed that painting or the excerpt from the painting and they replaced it with the Deinonychus. Um, and a lot of people, I feel, I won't name names, but um, they felt like something was kind of lost
Mm.
by removing that and replacing it with just like a single dinosaur image. Um, so it's not necessarily nostalgia per se, for me at least, but it's nice to see that that mural itself is still up in its place, and we can still um, have that as sort of a point of reference to understand, not just the history of dinosaurs, as organisms, but also the history of dinosaurs as we've envisioned them. Um, so yeah, I think that'll be a nice centerpiece, or I guess side piece for the main room. Um, I am curious how they'll balance it out in terms of like the actual depictions aside from the fossils themselves. Um,
Right.
I remember I want to say early 2010s, they actually had this installation where you could like push a button and highlight a dinosaur on the mural,
Mm.
or not just a dinosaur, but any creature on the mural, and they would bring up an image showing what we currently thought it looked like, as opposed to the 1940s um, vision of it. And I thought that was a cool aspect. So I hope they keep that and maybe continually update it as long as things keep going digital. Um, but yeah, I don't know too much else about like what they're doing in terms of what it looks like. Um, I know there's a Tylosaurus that's going to be hanging from the ceiling attacking an Archelon. So so there's
Icon.
that. Um, and there's one other thing. Um, they redid the Macedon, I think. And I think I don't remember if the article I saw yesterday, it said something about how they're recontextualizing the sort of the human history hall, or I guess human evolution hall. Um, so like when you go through the Peabody, or at least when you went through the Peabody as it used to be, um, you'd go into the main hall where the dinosaurs are, and then you'd go through there to the mammal room, and then from the mammal room, which was like this very dark, honestly kind of it was somewhere between spooky and depressing, the mammal room, because there were like no lights in there, except for like the museum, like the lights coming from within the exhibit. But then you circle around through there and you get to the human evolution section, which was also pretty small, but it was just like essentially just a ring of skulls from what I remember.
Mm.
Um, and personally, I'm not very well versed in sort of paleoanthropology. Like I'm aware of what some of the more recent developments are, but like if you asked me to tell you like what do we know from the last 5 years, which is kind of a shame, but I couldn't really tell you that much. I just know it's more complex than what it was before, since the walking with dinosaurs, or walking with cavemen days. I can tell you that much. So yeah, basically, I don't know how up to date that was kept, but I'd very much be curious. Like, what I'd actually love to do would be to have some, like myself, and then like one or two other people who are very well versed in like mammal evolution and then like paleoanthropology, just sort of go through the museum and see what's been updated and how, I guess, how accurately it reflects things. Um,
Yeah.
yeah, well, that's sort of an aspirational, maybe sort of thing. But yeah, very much looking forward to it, and hopefully, working there within the next couple of years too.
Oh yeah, hopefully. I think it's a great idea to be honest. Because goodness knows the time and effort it takes to renovate and update museum exhibits is pretty extensive. I know
Mm,
with DC, for example, when they had recently updated their fossil hall at the National Museum of Natural History, and that was like 7 or 8 years in the making to to,
mm,
to put that together. And of course, what it ended up being in the end was completely different from what they had before. Um, it's a very interesting story. Um, Speaking of interesting stories, are there any particular recent discoveries in paleontology that you've been most excited about?
um, yes, and it kind of bounces between I guess what really catches my interest. So I guess if we go back to, I want to say probably the past week or so, obviously there was Perucetus,
Yeah.
um, which, regardless of where the size arguments end up going, I think the more interesting aspect of that is just, look at the vertebrae on that thing. Like what what is going on there? Like I saw the pictures and it looked like one of those Cheerios that like got really soggy.
Mm.
Yeah.
Um, so yeah, Perucetus, and then funny contrast to that, right before we started recording, actually, like maybe 30 minutes before, I saw this story about another basilosaurid whale that got published. I think it's
Oh.
called Tutsitus.
Yep.
And we within a week we found, or we've learned about, I guess, possibly the biggest basilosaurid, and now we have, I think, what might be one of, if not the smallest basilosaurids
Right.
in Tutsitus. So it's very ping pongy, kind of funny when stories bounce off each other like that. Um, the one that really caught my attention, though, within the past week was actually a new. This is another Triassic thing. Um, Two Triassic things actually. One was about um, I don't remember what the name of it is, but it's one of those early marine reptiles that we don't quite know where they belong yet, at least as far as I'm aware. Um, but it looks like it had baleen,
All right. Yep.
like straight up, or something very similar to baleen, and it was filter feeding, but it was like maybe 3, 4 feet long, so it wasn't very big, but it was still filter feeding. And then like a day or two later, another creature, I think from, I want to say Thailand actually. And this was from a coprolite actually, that was thought to be from a phytosaur that showed um, a bunch of different types of parasites, like um,
Ooh.
like worm type parasites.
Yeah.
I have to look back and see what groups they thought they were, but it was like egg capsules and like actual whole like worms apparently preserved in these things. And it's always funny that when I see stories, like I said before, that connects to something I've covered in a video. Because I've actually covered a story on Triassic coprolites a couple years back, and this was from something in Poland. It was I think a silosaur coprolite that had beetles in it, and they were able to name the beetles um, that were found in the coprolite. They had some of the same people at least commenting on the story. I don't know if he was involved in the research, but yeah, I interviewed him for that video about the silosaurs, and so it was just funny to see, oh, he's back again talking about about prehistoric poop. What has he found in there this time? Yeah, so that's sort of like the top, I guess, top 3 or 4 things from like just the past probably 8 days or so in paleo news,
Yeah.
for me at least. What about you guys?
Oh yeah. Well, it's funny you mentioned that. I think that's actually a pretty good segue for us to jump into our July nature news stories part of the show. Now, of course, how we're going to do this, Ade, because you are our guest, you're going to get first dibs. Ade is going to present a story that he chose for our news episode, and then Albert's going to go and present one story, and then I'll cap us off with one story. So we got 3 stories from each of us to kind of show what stories in July that we thought were the most interesting to talk about. So I think if we
Sure.
jump to the next slide, Ade, you have the floor. What do you have for us today?
Yeah, so this is another one of those stories that relates to the Triassic period and relates to something I've covered before in a video. So it was very serendipitous that this came out in July. Um, so we have a story about coelacanths. So what are coelacanths, in case you may not know? So coelacanths are these fish that are more closely related to tetrapods, so the four-limbed creatures like you and I, um, than they are to other fish. And this comes from the way they're the bones in their fins are structured, and some other actually genetic stuff that I might touch upon later in this paper or in discussing this paper. But yeah, the most famous thing that you might know about coelacanths is that they are the sort of the poster child for what are called Lazarus taxa. And so Lazarus taxa are, of course, they're named after the biblical character Lazarus, who was someone who Jesus raised from the dead to show, you know, that he could perform miracles. And so in science, a Lazarus taxon is a creature that, or any organism that was first known from fossil remains and so was thought to be extinct. And then later on, it was realized, at least by Western science, that, oh, they still exist here today. And the coelacanth is sort of the most famous example of that. They found, or by they, I mean, there was a trawler vessel in like the 1930s, late 30s, I think. And they pulled up a coelacanth off the coast of East Africa, or South Africa, actually, on the Eastern Cape. And the whole story regarding that is actually kind of funny, but I covered it in the video. But essentially, there was a ichthyologist, Courtney Latimer, who she was always by the docks and was asking the trawlers to report to me anything interesting that you find, that you drag up from the depths. And so one day he drags up this creature that's got like these weird paired fins. It's got these big eyes, this really beautiful but weird texture, these like really, really thick scales, and then like all these like lobe fins all across its body, and the tail looks funky. It's like, what kind of fish is this that I got here? And so she comes by. She doesn't know what it is. It's not in any of the field guides. She takes it back to the museum. This is in East London, as they call it, in South Africa. Shout out to a friend I have who lives over there. She finds it very amusing that I know this much about this specific fact about her hometown. But yeah, she brought it back to the museum, tried to have it taxidermied, reached out to another South African-based ichthyologist. I believe his name was J.L.B. Smith, and this is like just before Christmas break for them, so she was like struggling to get it, to get it somewhere where she could preserve it or get it preserved. So it had kind of decomposed by the time he got to her. But when he did get to her I think the following month in January, he was like, "Oh my God, you have a coelacanth on your hands." And so he named it after her. So the genus name is Latimeria, and Latimer's Landing is the spot on the dock where she first saw the fish. Now, mind you, East Africans across the coastline actually knew about coelacanths, and various people had their own words for them. And this is the same actually for the other coelacanth species that currently exist today. So there's two of them. So there's the East African coelacanth, or the Gombesa, and then there's the Indonesian, I believe, based coelacanth. I forget what its actual sort of name is, but there's two of them, and they both live in these sort of deep sea trenches, kind of just off the coast of their respective islands. And so because they're down there, and because fossil coelacanths have been known for decades prior to their sort of the discovery of the living ones, this thought of, oh, coelacanths, they're really ancient, but also the ones that we have here, they don't look that much different from the ones that we have from the fossil records. So the idea was that, oh, they haven't changed. They're living fossils, right? And so that led to this sort of long-standing misconception about both how evolution actually works in some respects, and then also sort of an underappreciation of how unique both our living species are, but also how diverse coelacanths in general were across their evolutionary range, or evolutionary history, And so as you continue digging through, literally digging through the rock record, in the past couple of decades, there's been more coelacanths that have been found that show a wider variety of body shapes, and a lot of them don't. Some would say they don't look too different from the modern coelacanths. Like you can see the proportions are a little changed up, but they're essentially doing similar, or at least it's thought that they're essentially doing similar things, or they all at least look kind of samey, even if they're like, you have the ones from like North Africa with Mawsonia, or I believe Axolotl is the name of the other one. Um, but like these giant car-sized coelacanths that were hanging out in the rivers with Spinosaurus and whatnot. Um, so obviously they're not deep ocean dwellers, but they're in rivers. Okay, they're big. A lot of people are just sort of overlooking the differences between them aside from size. But then in the past maybe 10 to 20 years, there's been this boon of um, coelacanth fossil findings that are showing that they really were doing some pretty wild things with their anatomy, and a lot of this comes from the Triassic period. Now, why the Triassic period? Well, obviously this is at the tail end of what they call the Great Dying, which is when pretty much almost everything went extinct. I think the estimate is something like 85 to 86, up to maybe even 92%, depending on who you ask, of at least animal and plant life was just eliminated from both the land and the oceans especially. And so those animals that did manage to survive, they got to diversify pretty rapidly, to take over, and fill in at least all these different ecological niches that were now open. And so the video that I did on two of these coelacanths, one of which is pictured here on the left, Phorea maxcuni, um, a lot of coelacanths hopped in on this diversification trend. And again, it was known for a while, at least from the fossil record, that Triassic coelacanths seem to have been the most, at least speciose. But it wasn't quite recognized that they were actually morphologically, doing different things, until the past decade and a half, with examples from Canada, like you have Rieppelia, which is basically a coelacanth that looks like it's doing a barracuda tuna type of thing with its tail. Um, I want to say it's maybe like 3, 4 feet long. We don't have the skull of it, but everything else shows that like this was an animal that was like open seas, pretty high in the water column, and just chasing after prey, like actively running after things, as opposed to, or running, or swimming after things, as opposed to, say, our modern coelacanths, which they're more very much sit and wait and then maybe suction feed kind of creatures, and they'll hang out in their caves under the sea. But then you move forward in time a little bit, so from about 250 million years ago, shift forward to about 240 million years ago, to the mid-Triassic, and specifically we're talking the Swiss Alps. So within the past decade now, there have been a number of fossil species of coelacanths coming from the Swiss Alps, which, funnily enough, used to be underwater during the mid-Triassic before volcanic activity sort of raised them above the sea level and kind of ruined all the reefs that were there. So it was a very brief period of time, actually, that this sort of habitat was available. But during that relatively short sliver of time, the coelacanths there really diversified. And so this new study describes the species that is pictured on the right of this image here, Rieppelia heinzfurreri, excuse me. And this was one that was found, I believe, maybe 2 or 3 years ago. For context, the one on the other side, Phorea, was found a couple years prior to that, found and named a couple years prior to that. And so these are two fish that are living in the same place, right about the same time as each other. And it turns out they're actually each other's closest relatives, which is funny considering how different they look. But not only that, the study found or looked at both Phorea and Rieppelia, as well as two other coelacanths that lived in the same place and time, which looked more, if you will, normal, um, and found that they all form this clade that the paper calls Thysanopominae. And Thysanopominae are, as of this paper's publication, the sister group to the Latimerinae. So Latimerinae being the group that includes our modern Latimeria coelacanths. So these aren't, these are not ancestors to today's coelacanths. This is their own group of coelacanths doing their own weird variety of things. Um, and so what this paper did that I found particularly interesting was that they looked at the coelacanth genome um, and sort of hypothesized what sort of changes in the expression of different genes might have resulted in these weirdly sort of inverse proportions that Phorea and Rieppelia have, both relative to each other, but then also relative to Thysanopomis, which is kind of their sort of model regular coelacanth in this case. Um, and so, to be clear, they're not explicitly saying like we looked at the genes of these fossil coelacanths, because that's obviously not possible. But what they did was they hypothesized, okay, like we know certain genes do certain things, and they're kind of um, ubiquitous, or at least they have at least homologs in a lot of species, a wide swath of species, vertebrates at least, or I should say tetrapods at least, um, and then including also coelacanths within that group that it applies to. So we know these things function a certain way broadly, so we can sort of just take some educated guesses as to what might have needed to change in order to get the sort of body types we have here. They looked at the hedgehog gene family, um, specifically the sonic hedgehog and then the Indian hedgehog gene family. And for clarification, for anybody listening, sonic hedgehog and Indian hedgehog genes, they were not named so because they were found in hedgehogs. They were actually, if I remember correctly from the story my professor told me when I learned about this, um, it was just a name that they were given. Um, I think because they were playing the game or something at the time. Like the name is not that deep. It's not as deep. The name isn't as deep as you might think it is. Sometimes scientists just like to meme, I guess. Um, but notwithstanding that, these are two sets of genes that are very important in the development of different parts of the body um, in tetrapods and coelacanths is part of that because I don't think coelacanths are technically tetrapods.
Yeah, but lobe finfish.
Yeah, lobe finfish. I'm trying to remember the proper term for
Sarcopterygians.
right, Sarcopterygians. Yeah. So within Sarcopterygians, the hedgehog gene family is a pretty important group of genes that regulate developmental function. So sonic hedgehog specifically, at least in coelacanths, um, is involved in craniofacial development, and Indian hedgehogs or Indian hedgehog genes, at least in fish, they operate on the opercle and the differentiation of cranial dermal bones, so essentially different parts of the skull. Um, the opercle specifically is this large, um, this large sort of somewhat triangular shaped bone that's kind of on the sides of the heads of fish. I believe the gill is connected to that, or it's dependent on the fish, but underneath there, it's like one of the scales that covers the gill area. So they looked at that and actually hypothesized these different pathways for when these genes would have had to be activated versus sort of deactivated, depending on the sort of direction that the morphology was going in. So you have things like, oh, this one controls whether the bones in the skull fuse together. But yeah, Rieppelia has several fusion points in its skull bones that something like Thysanopomis does not have. These remained unfused. Phorea has some fusion, but not in the same places or in the same ways that Rieppelia has. Um, so there's, that's one set of differences. But then also, because they're sort of related to each other, a change in the expression of one can affect how um, other parts of the skull are developing. And so you have like Rieppelia has this massive opercle versus Phorea has this really small one.
Mm.
But then Phorea has this, this weirdly massively raised sort of point on the top of its head,
Yeah.
um, coming from this group of skull bones here that, in Rieppelia and Tysonopomus are either very small or just, are obviously nowhere near as developed. Um, but then, there's also some sort of shared features in terms of, oh, here's, you know, we're going to enlarge the first pectoral fin, or excuse me, not pectoral fin, enlarge the first dorsal fin. Um, Obviously, Phorea took it to proportionally, new height, but they all sort of have that sort of enlarged first dorsal fin going on. Um, but then, again, you have this back and forth with like Rieppelia has these really, really largely developed pectoral fins, whereas Phorea has these little, tiny little dinky things. Um, and so, all this sort of genetic back and forth and all this modification going on within, a pretty short span of time. Like these are animals that are evolving, within maybe 1 million, 2 million years tops
Mm.
to get this level of diversity. It's not something that it was thought for a long time that coelacanths themselves could even do. Um, and so the question that the questions that these papers and this one particular raises is, again, why don't we seem to observe that in the overall history of coelacanths in general? And so there's two sort of alternating hypotheses that may not be mutually exclusive, but it's going to take more work to suss this out. Obviously, there's a question of, are we just looking at gaps in the fossil record? Because, these two species, Phorea and Rieppelia, or these two genera, I should say, um, they were only discovered within the past decade.
Mm.
So obviously, we still have more things to find. We have to keep looking for things. Um, we actually don't know, as far as I'm aware, um, what the actual fossil record is for the lineage that led to our modern coelacanths specifically. So even the assumption that modern coelacanths are somehow like, the baseline for what coelacanths as a whole were is probably a misleading conclusion.
Mm.
Um, because again, historically, we have coelacanths in rivers, we have coelacanths here in these reefs, these shallow reef systems. We have coelacanths in open water feeding high in the water column. Um, so, it really, our perception of, the living fossil taxon, or not, excuse me, the living fossil idea, with this example, just, needs to be completely overhauled, if not discarded
Mm.
entirely, because clearly that's not what's being represented um, in the fossil record, or it's not what's being represented, in practice, essentially. Um, and that kind of applies to a lot of other groups too, like the crocodilomorphs, or modern crocodiles at least, are very specialized
Mm.
um, for what they do, and like the ones we have today, the 23 or so species we have now, are just a small sliver of the diversity that we had, like just morphological and ecological diversity that we had, even going back a couple of thousand years.
Mm.
Right.
Um, Never mind the entire span of the last what 250 or so million years that their entire crocodilomorph lineage has existed. So yeah, so I just thought it was interesting to really see that being broken open with coelacanths. Um, that said, there is some potential genetic stuff going on that might be limiting factors on how much coelacanths can rapidly adapt. So we know they have the capacity to do it, obviously through the fossil record in this example, but Um, the paper did highlight that there are some special conserved, what they call cis-regulatory midline enhancers in coelacanths, or at least in modern coelacanths. So whether these existed in ancestral coelacanths is an open question, but it has been observed that coelacanths do have a relatively slower rate of um, sort of molecular evolution, at least. And so the question is that just because they're in a good spot, they don't need to necessarily evolve as quickly, even though they are still evolving, at least on a molecular level. But like stabilizing selection is a thing too. Um, so is it really stabilizing selection that's acting here, or is there really some actual constraint that's been going on within the lineage, or at least their lineage of Latimerinae, um, that we might be overlooking that could help answer this question of why was there a burst in the Triassic and then not as much craziness, later on. So yeah, that's the set of open questions that this paper leaves behind, and I'm personally my biggest thing about it is just like you know all the diversity. Look at this. Look at these fish. Like
Yeah.
you wouldn't imagine this sort of thing. Um, Never mind just seeing all of them living at the same time. It's just sort of wild.
Hmm.
It's a wild thought. Like you're looking at three different species here, if not four. Um, Whereas just today we have only two. Um, and to think there were so many more doing all these other things potentially across the world at this time. It's just I always love these little slivers of these slivers of like the wide spectrum of things. So yeah, that's the story that really caught my attention from last month. Do you all have any things you would like to add or thoughts you'd like to throw out there about this?
One thing that I'm curious about, it's a fascinating paper. I agree with you, and it's very good to see kind of these persistent myths about animals that get dispelled, right? Like the coelacanth. Even like nowadays, when I see people talk about it, like the living fossil thing is always brought up, even though we've had all this research in just the past few years that has clearly shown that they've had their own unique history in this into deep time. Um, I'm curious as to what many of these different coelacanths were doing in an ecological context compared to other types of fish that would have been around. Because I'm pretty sure the the ray fin fishes, the actinopterygians, were kind of getting their start in the Permian and Triassic, if I'm not mistaken.
Yeah, I think they were spreading out at that point. Like there's two really well-known Triassic taxa, I believe. Psorichthes is one, I think Bergeria is the other one, and they're pretty much found throughout the entirety of the Triassic. Um, I want to cautiously say one of them might have gone into the early Jurassic, but don't quote me on that. Um, but I know it's been hypothesized actually in the case of Rebellatrix, going back to the Barracuda coelacanth essentially, um, that it actually might have been outcompeted by these two. Now this is just something that was just hypothesized very loosely in the description paper, I think, for Rebellatrix, and this is back in I want to say 2012. But yeah, it's a thought that maybe these particular ones, I don't know, maybe they weren't uh, as generalist as some of the other ray fin fish were at the time, and so they were sort of just like a blip um, in the scene
Hmm.
overall. But I don't know. It's definitely something that it has been looked at, to my knowledge. Whether there any conclusions have been drawn from that, that's a TBD.
Yeah, because I know coelacanths seem to have suffered pretty hard in the KPG. Um, do we have any like Cenozoic fossils?
I think there's one, maybe one or two, but they're not the best, if I recall correctly. I think Trey the explainer did a video covering this, um, and he mentioned, yeah, the coelacanth fossil record is pretty scrappy after the Cretaceous. Um, but I guess that also is, open question as to, where did they go? Because obviously we have the ones the ones around today that just pop up out of nowhere. So
Yeah,
maybe
and
they
they're
were already deep sea. Mm,
yeah, that's what I was thinking because like they seem to be pretty deep water fishes to begin with. So I imagine the opportunities for preservation probably haven't been there if they had moved to that niche at a very early date following the APG. Um, yeah, that's a good question. Um, Albert, do you have anything you wanted to add or ask about?
Uh, well, I also noticed this story during the past month, and I agree it's very fascinating. We have talked about coelacanths on the show that I recall, but the story that we covered was on extant coelacanths, and it was a study looking at how long they could live, not in terms of
mm,
how long um, they've been around in the fossil record or through evolutionary time, but in terms of like individuals, how long can they live? And it turns out that they can live for a very long time, apparently. So I guess in a sense they could be described as living fossils in more ways than one, but as this story shows, that's a kind of misleading description when we're trying to apply that to their evolutionary history. And so this was really cool. I also remember when Forea was described too, and I remember thinking, wow, that's a very cool looking fish. And so it's definitely fascinating. And this is one of those things that we wouldn't really have any idea about if it weren't for the fossil record. We wouldn't know that coelacanths once came in all these amazing forms if not for the fossil evidence. So it really goes to show like the things that are out there to discover. And it is also really interesting that they were able to apply what we knew about development in modern coelacanths and modern lobe-finned fishes to try and figure out what might have been driving the different kind of body proportions in these ancient ones. As you said, there's no way we can actually study the genetics of such ancient taxa directly, but uh, it is very cool that we are able to apply our knowledge of living species to kind of make the past a little bit clearer. So, yeah, I think this was an excellent choice of a story, and it certainly fits in with your Triassic theme. And
yeah.
so, yeah, thank you very much for sharing.
No, of course. I'm very curious to see what you guys have.
Yeah, well, if you like, we can jump to our next slide. And Albert, I believe you will have the floor next with a another kind of fishy tale for us today.
Yeah, funnily enough, if that is true. Um, my story that I picked for this month is also about a fossil fish, but it does differ in some important ways from the coelacanths we just saw. Um, First of all, this is a fossil ray, so it is a more distant relative to us than the coelacanths were. So both us and coelacanths are sarcopterygians, as we covered earlier, lobe-finned fishes. Whereas rays are a group of cartilaginous fishes, like sharks. And cartilaginous fishes are about as distantly related to us as you can get while still being a vertebrate that has jaws, at least in the modern day. Among living vertebrates, the only ones that are less closely related to us than cartilaginous fishes are jawless forms, such as the hagfishes and lampreys, which we have also kind of touched on in the past as well. And we've talked about cartilaginous fishes in previous news episodes, but I don't think we've done a story on rays specifically. I think the last one we did was on a different group of cartilaginous fishes called the ratfishes, which are a pretty obscure group. But rays and sharks are much better known. An argument could be made that the general term shark could be applied to all of the cartilaginous fishes, and certainly I know a lot of people, at least involved in paleontology, will, in a kind of informal sense, call all different types of cartilaginous fishes sharks, even the ones that aren't strictly members of the modern shark diversification.
Right.
Yeah, and this is kind of interesting when it comes to the relationships among the cartilaginous fishes because it has actually been traditionally thought that rays were a group within the modern sharks, basically. This was based on their anatomy. It was thought that some types of modern sharks were more closely related to rays than others, and therefore rays should be considered like a type of shark as well. But that hypothesis has been overturned by genetic studies more recently, and it turns out that all the modern cartilaginous fishes that we call sharks do kind of form a separate lineage from the ones that we call rays. And so, in that sense, kind of rays are not sharks. But again, if you apply kind of a broad kind of definition to the term shark, if you cover all cartilaginous fishes with that, then okay, yeah, like you can still kind of consider ray sharks. And I know like some, I guess, conservation organizations. I think on social media, for example, they'll use the hashtag like Flat Shark Friday to kind of promote awareness of rays. So, in an informal sense, like you could say that these are all kind of sharky critters, at least. But in any case, at least it can be said that modern rays and modern sharks are close relatives to each other, but forming separate lineages. And I think rays are pretty cool. I would say rays are probably some of my favorite groups of fishes, to be honest. They have just such a distinctive look about them. Just look at that very, very flat body with the very broad pectoral fins. It's a really distinctive look that stays with you. So I think for almost as long as I've been alive, I think rays have been some of my favorite fishes. So I'm pretty excited to cover this story. Now there are many different types of rays. But some of the most familiar, I think, and the group that this story concerns are the stingrays. And as their name suggests, stingrays are so called because they have several spines on their tail, which are connected to a venom gland. So these are venomous spines on their tail. And the rays basically use this or these spines as a defensive kind of weapon. And occasionally that puts them into conflict with people. Sometimes people hanging out at the beach get injured by stingrays that are hiding in the sand. In a few very unfortunate cases, people have been killed by stingrays using these tail spines. Of course, one of the most infamous and certainly a very, very tragic example was the death of the Australian wildlife presenter Steve Irwin, who was killed by a stingray in this manner. Now, it should be emphasized that stingrays are not aggressive animals. So the tail spines are purely defensive weapons. They're not like swimming around attacking other things with the spines. In fact, even when they are disturbed, stingrays would much rather either hide in the sand or try to swim away from danger. In fact, from what I know, I don't think we actually have many good observations of stingrays like actually using their tail spines against their natural predators. So in the wild, mostly they would be preyed on by large sharks or orcas. But I think there are actually very few recorded observations of people seeing stingrays using their spines against these types of predators. So it's not something they actually do very often. And Steve Irwin was very, very, very unlucky, like incredibly unlucky when it came to that stingray encounter because the tail spine happened to like penetrate his heart. And of course, anything penetrating your heart is pretty much a death sentence. If it weren't for that, most of the time stingray kind of inflicted wounds are very much survivable for humans. Fatalities are very, very rare. You would have to be like struck in that kind of freak accident in a very vulnerable spot for it to be fatal, at least under normal circumstances. And so yeah, it's a definitely a very, very tragic incident, but stingrays aren't really out to get you or anything. They are definitely not aggressive animals. In terms of how stingrays live, this is this is something that is kind of reflected in kind of the two major body plans that are seen in stingrays today, and this has a lot to do with the importance of the fossil taxon that we're going to describe or going to talk about in this story. So I guess the kind of typical stingray body plan, so this body plan that they started out with, and most of the major groups still have this body plan, it is a shape that is usually kind of round overall, if you view them from above or below, or somewhat diamond shaped maybe. And most stingrays like this, they live close to the sea bottom, and that's where kind of that flattened shape comes in, right? Because that allows them to kind of stick close to the seabed and kind of lie flat there. It helps them hide in the sand very easily if they need to hide from something. And so your typical stingray, it would be something like this. It would be living close to the seabed, and the way that they swim, if you ever observed like a stingray like this in an aquarium, for example, or in the wild for that matter, you might notice that they don't swim by kind of flapping their entire pectoral fins up and down as you might expect. A lot of the time what they'll do is they'll kind of send these ripples along the margins of their fins. And so they have this kind of undulating way of swimming. That's what they're called. So they undulate the edges of their pectoral fins to swim along. And what gives them that rounded shape is that kind of the pectoral fins are sort of fused to the sides of their head. So there's no kind of clear demarcation between where the head is and where the fins are. So the entire kind of ray is just this disc with a long tail. And so this disc that is formed by the head and the pectoral fins combined is used by these stingrays for both swimming, so they send these kind of undulating waves along the edges, but also for manipulating food. And what stingrays like to eat are other things that live on the seabed. So they like to eat worms and crustaceans and mollusks, like hiding in the sand. And so they'll basically use this entire disc structure that they have formed by their head and their fins to manipulate their food. And so, like, for example, they can hold it down against the seabed with this disc structure, or kind of move it around to shuffle it close to their mouth where they can actually eat it. And speaking of their mouth, kind of a typical stingray kind of dental apparatus, so their teeth, is formed of like many small teeth, kind of arranged in rows, like a rows a lot like a shark's teeth, but unlike a shark, the teeth aren't sharp, so they have these kind of low, rounded teeth. And in most stingrays, these teeth are quite small, and they're suited for kind of grasping these, aquatic invertebrates that they might like to eat. And so they'll grab things with these teeth from the seabed. Also, like they'll use like suction to kind of pull stuff from the seabed as well, and then kind of crush it in their jaws and eat it. And so that's the way that a typical stingray kind of goes about its day. And stingrays with this kind of body shape have been given a term called radiobenthic. And the term benthic means things that live close to the seabed, so things that are towards the seabed. And so that certainly kind of describes the usual habitat of these rays. The term radio comes from the genus Raja, which is not a stingray, but a different type of ray called a skate. But skates actually live in a very similar way to these radiobenthic stingrays, and so they probably this term was coined to kind of describe any kind of ray that lives in this manner. And so basically, if you're skate-shaped and you live close to the bottom, you are a radiobenthic ray. But what's really interesting about stingrays is that there is one group that has kind of evolved away from this kind of lifestyle. And instead of living close to the seabed, they've kind of raise themselves off into the water column, and they actually spend a lot of time swimming out in the open ocean, which is about as far away as you can get, from like the ancestral condition of being a ray living on the seabed. So these rays have become adapted to kind of swimming, actively swimming out in the open, And to do this, they have several different adaptations. First of all, their pectoral fins have become much longer, much more elongated and narrower, and they have like structures inside them that stiffen the pectoral fins, so they can actually like flap the pectoral fins up and down. And so this might be what you would more intuitively imagine how a ray would swim. They adopt this style of swimming called underwater flight, and in addition to that, their fins have kind of become separated again from their head, so the head actually protrudes kind of in front of them. You can see that they actually have a separate head that is not included in just like a single round disc with the fins. Now, this means that the fins can kind of do full-time duty for swimming, but it has been suggested that this comes at a bit of a disadvantage, because without this kind of complete disc formed by the head and the pectoral fins together, it might be a lot harder for these rays to manipulate their food, like the radiobenthic rays can do, since the head is now separated from the fins. So possibly to make up for this, these open ocean rays have evolved another set of cartilages. Well, I say it's another set, but they're actually evolved from the pectoral fin cartilages. But they are now separate from the pectoral fins themselves, and they're called cephalic lobes, so head lobes. And so they have these set of cartilages like on either side of their head, and so they use these cartilages for manipulating food instead. And in fact, they probably also have a role in detecting prey because they have sensory organs on them. And I mentioned cartilages earlier, as I remember, like these are cartilaginous fishes, so their skeleton is primarily formed of cartilage and not bone, unlike in us. When it comes to the cephalic lobes, the most obvious examples would be in one of the most specialized groups of these open ocean stingrays, which are the devil rays, which include manta rays, which you might have heard of. These are the largest rays in the world, and if you've ever seen a picture of a manta ray or been lucky enough to see them in real life, you can see that manta rays have these kind of strange projections on either side of their head, and so those are kind of modified cephalic lobes that they have. And in manta rays, they probably use those lobes for kind of directing food into their mouth, and so it still kind of has that function in at least interacting with their food. And so speaking of food, well, what do these kind of open ocean rays eat? Well, it turns out that a lot of them eat harder types of prey items than the kind of radiobenthic rays do. So in these open ocean rays, the teeth a lot of the time have become a lot larger, and so because they become a lot larger, they're also fewer in number, and they form this kind of interlocking surface. So the different teeth, next to each other, form this kind of pavement pattern along the edges of their jaws, basically. And so this allows these rays to kind of crunch up very hard-shelled mollusks, especially. But there are a few species, or at least there is one particular group that has evolved away from this further still. And so these are the devil rays that I mentioned earlier. And so the devil rays have reduced teeth, and they do not feed on very large prey items, but instead feed on plankton, and so that's where those kind of projecting cephalic lobes come in the manta ray, and so they kind of swim through the water column and scoop plankton into their mouths, and as they're doing so, the cephalic lobes probably help kind of direct the water into the mouth. And so those are some of the kind of the major adaptations of these open ocean rays. Something else that's worth mentioning is that whereas in the radiobenthic stingrays, the tail is often kind of very flexible and whip-like, so that kind of helps them kind of flick the tail in defense when they need to use that tail spine. But in the open ocean rays, the tail is often a lot stiffer, and it's used more as a rudder while they're swimming. And in many of these open ocean rays, in fact, well, in some of them, I wouldn't say many of them. In some of them, they have actually lost the tail spine entirely. And so things like the manta rays, for example, do not have a tail spine anymore, even though they are phylogenetically still stingrays. So these specialized open ocean rays are called aquilopelagic rays, and so pelagic means things that, or refers to things that are out in the open ocean, and aquilo comes from a word for eagle, aquila, and that's because these rays have these very elongated pectoral fins that look like wings, at least a lot more like wings than a radiobenthic ray's fins look. And indeed, many of these aquilopelagic rays are called eagle rays, and they are quite spectacular. And there are quite a few aquariums that keep aquilopelagic rays as well, like many of the eagle rays and a group called the cow-nosed rays are relatively commonly kept in captivity in my experience. And so next time you're at an aquarium and see a stingray, you can kind of keep an eye out to see which type of stingray it is in terms of its ecology. And so these kind of two different ways of life for stingrays have long been known. They have like these very obvious differences. But because most modern rays can be kind of sorted quite neatly into these two different categories, we haven't really known very much about how the aquilopelagic form evolved, because most of the modern ones and kind of ancestrally stingrays would have been radiobenthic. So how do we get from a radiobenthic form to an aquilopelagic form? That is one of the kind of questions that this new fossil helps us understand. And so the authors of this new paper described a new species of ray, and it's known from a nearly complete skeleton. You can see the specimen pictured here. It's very well preserved. You can see like the soft tissue is the outline of the body is preserved, which is really, really good, because when it comes to cartilaginous fishes, as you might expect, since their skeletons are mostly not made of bone, most of the time we only find their teeth, which are the hardest parts of their bodies, or maybe the little scales that they have covering them, which are also hard, but not so much the rest of the skeleton. And so a lot of time we have a very hard time figuring out what extinct cartilaginous fishes actually look like. But here we have a very well-preserved specimen with the soft tissues that can tell us pretty much exactly that. Well, what did this extinct ray look like? And so this fossil comes from the early Eocene of Italy, so it's about 50 million years old, much younger than the coelacanths we were talking about earlier, even though this is a more distant relative to us. And it's very interesting because it seems to show a combination of both radiobenthic and aquilopelagic traits. So first of all, these authors named this as a new species, and they called it Dasyomyliobatis thomyorkei. And so what does this name mean? Well, the genus name, Dasyomyliobatis, is kind of a reference to two different groups of living stingrays. So dasyatoids, which are one of the radiobenthic groups of stingrays, and myliobatoids, which are the group of aquilopelagic stingrays. And so because this stingray has both radiobenthic and aquilopelagic traits, they named it after these two different morphotypes or two different modern groups exhibiting these morphotypes. Thomyorkei is named after the lead vocalist and songwriter of the band Radiohead, Thom Yorke. So evidently one or more of the authors on this paper was a fan, or is a fan rather. The type specimen is apparently a female individual, which can be told, I assume, because male rays, like sharks, have these specialized pelvic fins called claspers that are the structures that help them deliver sperm to the female while mating, whereas this specimen does not seem to have those claspers, and so the authors mention that this specimen seems to be a female. And but kind of most significantly, I guess, is the fact that this creature exhibits a combination of both radiobenthic and aquilopelagic traits that isn't really seen in the modern rays. And so, as examples of these different traits, when it comes to what makes this ray similar to radiobenthic rays. It seems to have a flexible pectoral disc, so the fins, for example, are not stiffened by the structures that would stiffen the fins in oculopelagic ray, and making their fins more efficient for flapping. And it does have some small teeth along the sides of its jaws, like a radiobenthic ray would have. But what's kind of interesting is that it also seems to have a combination of teeth that you would see in radiobenthic and oculopelagic rays, because the teeth that are closer to the midline of the jaws are enlarged and interlocking. Like they're not quite as big as they would be in a modern oculopelagic ray, but they're bigger than you would expect for a radiobenthic ray. And so it has a combination of these different types of teeth in its jaws, which is quite fascinating. And it has some other oculopelagic traits as well. So as you can see, its head kind of protrudes from the pectoral disc. So you can kind of make out it has a separate head from its pectoral fins. It's not just one single disc structure. And it actually has cephalic lobes on the sides of its head, and that's what the close-up indicated by the letter F here shows. It has those cephalic lobes, and so it has a combination of these different traits. And also, its pectoral fin proportions are kind of intermediate between the oculopelagic and radiobenthic forms, so they're not quite as elongated as you would see in an oculopelagic ray today, but they are kind of more stretched out than they would be in a normal radiobenthic ray. And so that is a quite interesting set of features, and the authors didn't only kind of base these interpretations off just kind of eyeballing the fossil and saying that these traits exist, but they did several different types of analyses to see, just how similar is this ray to modern groups of stingrays, as well as how it is related to the modern groups. And so their phylogenetic analysis, where they try to determine the relationships of this stingray to the modern groups, found that it does indeed seem to be most closely related to the aquilopelagic stingrays among all the living groups of stingrays, but it is a pretty distant relative to them. So it's like it's close to the split where the aquilopelagic rays would have diverged from other types of stingrays, and it just kind of falls slightly on the aquilopelagic lineage. Right as it was getting its start. So that does suggest that this stingray is perhaps a suitable model for the type of ancestor that modern aquilopelagic rays would have evolved from. And kind of mathematically, they tried to plot out the proportions of the pectoral fins compared to modern types of stingrays, and they were able to confirm that, yes, indeed, the fin proportions of Dasyomyliobatis are kind of intermediate in terms of how elongated they are between kind of modern radiobenthic and modern aquilopelagic rays. Now, interestingly, they found that there actually is a group of extant stingrays that also fall into this kind of intermediate fin proportion range. And that is a group of stingrays called the butterfly rays in the genus Gymnura. And if you've ever seen a picture of these, they are like really beautiful looking rays, and they do indeed have this kind of moderately elongated shape. And you can see where they get the name butterfly ray, because they do have like these kind of wing-like pectoral fins, but they're not quite as stretched out or as narrow as you would see in, say, a manta ray or an eagle ray. And in living butterfly rays, they are able to use these fins for both undulatory swimming, so kind of sending the ripples along the margins, as well as underwater flight. And so the authors infer that perhaps Dasyomyliobatis was doing something very similar. There actually is another type of fossil stingray known from the same time and place as Dasyomyliobatis that also has similar fin proportions, and that is Promyliobatis, which the authors found was probably a little bit more closely related to the modern aquilopelagic rays. So there are a few taxa that fall into this range of intermediate morphologies here. And so, overall, in terms of what Dasyomyliobatis was doing, the authors suggest that, well, it clearly is not as specialized for a pelagic lifestyle as the modern achilopelagic traits. Its fins are still really flexible, for example, and they are not as elongated. And it has some enlarged teeth, but they're not quite as big. So maybe it was still spending most of its time close to the seabed. But having all of these adaptations meant it was probably pretty flexible in terms of its habits. It could probably like swim around in the water column too if it wanted to for a pretty good period of time, and could probably feed on a wide variety of prey items with its different types of teeth. And so in doing so, it was probably able to exploit many different types of environments and food sources. And so what does it tell us about the evolution of achilopelagic traits? Well, it shows that these cephalic lobes, these kind of, this different set of cartilages on either side of its head, probably evolved before the stiffening of the pectoral fins. So they evolved before the fins became stiffened and less suitable for manipulating prey. Maybe the cephalic lobes originally had a different purpose other than prey manipulation. As mentioned earlier, they are also used for detecting prey. So maybe they had this kind of prey detection function first before becoming used for kind of prey manipulation when the pectoral disc was no longer so useful for that anymore. And so that's certainly one model that's suggested by this new fossil, and that again the kind of the sequence of how these traits evolved is something we would not have known without the fossil data. Now, when it comes to intermediate forms like Dasyomyliobatis with these intermediate proportions, the authors actually coined a new term for this type of morphotype, and so they kind of took a bit from column A and a bit from column B and call this type of shape achilobenthic rays. And so they are rays that have wing-like pectoral fins, but probably still spend most of their time near the seafloor, and so that's where that name kind of comes from. And on the next slide, I include a figure from the paper where the authors apparently commissioned some artwork to show what Dasyomyliobatis might have actually looked like when it was alive. And so here's their model of it. And so that's pretty cool. It would be really fun to travel back to the Eocene and watch this thing kind of flapping around, maybe just above the seabed. Do either of you have anything to add?
Ade, I'll let you go first.
Yeah, this is very cool little. Do we know what the size of this one is? I mean, I see there's a scale bar, but before I call it little, I wanted to know.
I didn't check. I did check the exact proportions or the size on this thing. I would have to go back to the paper.
But yeah, it's a very cool little creature, and I was thinking like I had two sort of thoughts about stingrays in general.
Mm-hmm.
The first one that really like intrigued me in general was the mention of the cephalic lobes.
Yes.
And how I think you said they were derived from the rest of the pectoral fin.
That's right.
Which is strange to me because now I'm like, what is the embryologic like development of that? Because I always thought they were just extensions of the head and kind of like a weird, I don't know, like a catfish's barbels kind of thing.
Right.
So I mean, yeah, I definitely need to look up like some ray embryology if that's actually been documented, because I'm very curious how that actually develops now.
Yeah, yeah. There has actually been some research that I'm aware of that's been done on the cephalic lobes, and in fact that's one of the lines of evidence apparently that shows that they are probably derived from pectoral fin cartilages. And I think it's a little bit less strange when you consider that kind of ancestrally the pectoral fin cartilages are kind of fused to the sides of the head in rays, and so that
Right.
which is in itself very weird, but it kind of makes sense that when you have a starting point like that they would be able to evolve the cephalic lobes from the pectoral fins.
Right. And then just the other thought is just like in general, like my own personal experience with rays or stingrays in general is interesting because you mentioned, Steve Irwin's unfortunate situation.
Right.
And funnily enough, the first time I saw a ray in the wild was like I think maybe a summer a summer or two like after that happened,
Yeah.
and like my family used to go down to see relatives in the Caribbean, and so they have both, the um, they have both Rajabenthic and Aquilopelagic rays there.
Mm.
Although for the most part, I was just seeing, the sand living ones.
Right.
And the first time I actually saw one, I was, creeping along on the sand bottom, and I saw this twig like right in front of my face, and I like my eyes traced it back, and I saw a pair of eyes sticking up out of the sea, out of the sand,
Yeah.
and I just freaked out. I was like, "Oh my God, it's a
Right.
stingray!" Stood up and ran out. But yeah, since it didn't move or anything, and that's just sort of been my experience with them since I've gone back and seen them over the last decade and a half since then.
Yeah.
Like they're very chill animals.
Yeah.
Um, like I've gotten unintentionally, like that was actually the first time I've gotten in their face literally like a couple times now,
Hmm.
and they don't freak out or anything. They just like turn one eye up towards me and just keep cruising along.
Right. Yeah.
Don't even like make a motion to defend themselves or anything. And this is all in water that's like maybe 3-4 feet deep tops.
Wow.
So yeah, and then right after that, like the last time I was able to go down there and see them, as we were leaving the beach actually, and it was a sunset, so it was very scenic kind of thing. These eagle rays actually started jumping out of the water just
Oh
beyond the
wow.
buoys.
Ooh.
So, and we just seen I don't know what specific species they are down there, but one of the Rajabenthic types of rays, I want to say maybe the Caribbean reef or something. I'm probably making the name up, but one of the more common ones down there. And I was just always thinking, I've never seen the eagle rays before. And
Huh.
then literally, as I'm thinking the thought, I turn around and I just hear splashing, and I'm just like, they're just jumping out of the water. I'm like, wow.
Wow.
So very fortunate to have encountered both of them.
Yeah.
So yeah, very cool study. To think that they've been around, so long, and just to see that sort of split happening is cool. I'd actually one more question now that I think about it, because you mentioned the butterfly rays.
Hmm.
Do we know if the butterfly rays phylogenetically sort of plot closer to, um, I guess, closer to more Rajobenthic rays than they do to? I mean, obviously there's well, maybe not obviously. That's why I'm asking the question. But is there like a morphological grade as you go along the aquilopelagic ones,
Right.
or do some revert back?
Like to my knowledge, the butterfly rays seem to be more closely related to some of the radiobenthic rays than to the aquilopelagic rays. So they would be sort of an independent evolution of a more kind of aquilopelagic-like body plan, or in this case, I guess an aquilobenthic, as the authors term it, body plan. So yeah, it seems that they've happened. Transition has happened at least twice in the stingrays. Even though in the butterfly rays they haven't gone like fully aquilopelagic yet. And incidentally, kind of harkening back to your earlier question, because I just looked this up in the paper, the authors report that Dasyomyliobatis is about a meter long in terms of total width, like from wingtip to wingtip. So it's not one of the biggest rays ever, but it's a decently sized animal, I guess.
Mm. Yeah, friend sized.
Yeah, indeed.
It's got a little bit bigger than the rays that I'm used to seeing. Of course, my experience with rays is mainly from touch
Oh
tanks,
yeah.
right, at like zoos and aquariums, where I mean you get more of an understanding of like what it means to be a cartilaginous fish. Obviously, like you touch their bodies and like they're kind of rough.
Yeah.
Um, the way that their scales are arranged, and it's interesting to see just kind of like how quick bursting they can be.
Yeah.
Like obviously, a
Mm.
lot of these fish tanks they have feeding stations where you can feed them like peeled shrimp and stuff like that, right? So they see a hand and they immediately associate it with food, so they all just come bursting to the side of the tank, flapping around. Um, and like if you're in a situation where their mouth is like clamped onto you, like it feels like a vacuum cleaner. It
Right.
doesn't really hurt, because the teeth are not that sharp.
Mm.
So it's an interesting experience. But those are mostly the cow nose rays. Those
Right.
are the ones that they're common on the East Coast, so they feature a lot in the aquariums and zoos there. But yeah, I agree with Ade. It's really neat to see. I guess like kind of like one of these kind of like visualizations of a great transition in vertebrate biology, where you have kind of a sort of change between two body types and ecological behaviors within rays that we didn't really have before.
Mm-hmm.
Um, I imagine if we hadn't found this fossil, we would have probably speculated with the butterfly rays, like possibilities, like, oh, maybe the change could have looked like this. And now we can actually see that in the fossil record as a possible example of that.
Mm-hmm.
Because obviously, like, we're not saying
Yeah.
that Dasyomyliobatis is the transitional form that gave rise to the aquilo-pelagic forms, but probably looked very similar, if anything.
Right.
Um, Also, what a gorgeous fossil! I mean, the
Oh
skin
yeah.
impression there. I almost feel like I can reach out and touch it and feel
Yeah.
like one of those rays at a touch tank. Like it's just amazing to me to see that. Um, that's very cool. Well, thank you for sharing that with us, Al.
Of course.
Um, I guess we can move on to our final story on the next slide.
Sounds
Now,
good.
unfortunately, like it's not a fishy story, but I guess it kind of can be because humans and lobe-fin fishes and all that kind of stuff.
We're also moving forward in time.
I noticed that too. We kind of worked that out. Um, but no, this is kind of this is a story that I really wanted to pick because like the day it came out, I was just losing it because I did not realize we were at a point with ancient DNA studies that we could do something like this.
Hmm.
So I guess kind of to jump into it. So one of the great traditions in sociocultural anthropology is understanding kinship, being able to place individuals on a tree of relatedness and showing how members of their families are to be properly addressed in their language. I have very strong memories of being in Dr. Robert Bunger's class at East Carolina University, where he taught about human societies. And I learned about the particularities that different peoples use to refer to their relatives. Obviously, if you grow up in sort of like a Western Euro American background, um, you're used to thinking in very basic terms about your family members, right? Like you have a mom or a dad, brothers and sisters, and aunts and uncles, and that's pretty simple. But there's actually a lot of variation among different human societies. So, for example, people may use the term wife or grandmother or aunt for multiple people of similar age or social status. And there's copious research that exists for contemporary societies. But what about in the deep past? Can we ever come to know how human communities in prehistory were related to each other and how they came to view each other? Well, unfortunately, the latter would be next to impossible without written sources or oral histories. But in the new and exciting age of ancient DNA, we may have come ever closer to accurately reconstructing long lost genealogies than ever before. And so this was a pretty landmark paper. Maite Rieppelia and colleagues set their sights on a relatively recently described locality, which is over 100 kilometers from Paris, France. This is Gorges-les-Nossons, and it was discovered to be a community grave site that dated back to the Middle Neolithic period. So that's between 4850 to 4500 BC and belonging to an archaeological culture called the Cherney Cultural Horizon, which is then associated with the ancestral linear pottery culture. So these are some of the earliest farmers that are entering Western Europe from the Anatolian region
Mm.
in the deep past, which began about 9,000 years ago or so. Now, the majority of research on Neolithic, and of course that means Stone Age agricultural social relationships, has been done at megalithic sites where these giant stoneworks like Stonehenge were erected. And during the time of Gergy-les-Mossons, present day France was experiencing what archaeologists call the Passy phenomenon, which is a complex of monumental funerary architectural structures that were built across the landscape over different societies that seem to have been solely dedicated to just one individual or a group of individuals who must have had some sort of importance in their communities. Um, Now, the Gurgi site contains no megaliths, however, but given that some 128 people, adults and children, have been uncovered, that makes this site the largest of its type in the Passy phenomenon. And there are like some architectural details that are apparent, as are how some of the people were laid out. But grave goods are few, which limited what archaeologists could interpret regarding potential social relationships, beyond the fact that because there were so few grave goods, they were probably not likely a community with any great high social status, like chieftains or something like that.
Hmm.
Thankfully, though, the team figured that one possible way to find out was to sequence DNA from as many of the graves as they could. So, out of 128 individuals, the team sampled 110, from which they were able to get 94 genomes. And 22 of these had already been published in previous work, so they just kind of combined those efforts together. Um, they also obtained immune data from 82 of the 110 surveyed, and specific DNA from the mitochondrial genomes and Y chromosomal genomes were also gathered from 99 and 57 people, respectively. Then they also acquired strontium isotope data, which was also taken from about 57 people, to help with dating when the bodies were deceased. So there was a huge sample size of data here, and this was just enough to create a sizable pedigree of the type that families use today. And so this is shown in the graphic here to the left. You can see that very clearly. Um, so, what was the nature of this Neolithic community? Well, the first big surprise was that the vast majority of people in the gravesite belonged to just two family lines that spanned back 7 generations. So
Hmm.
pedigree A is shown beginning to the left, so the colors from red to green. That's the largest here. Pedigree B is on the right, mainly in blue. Although there were several people who, at the time of the publication, they could not be linked to any of these, and their relationships were a bit unclear. So, like those are those in the middle here in gray and purple. And of course, caveat here. In describing how these relationships seem to have been recognized, the team did use categories like mothers and fathers, sons and daughters, males and females. And while these are admittedly modern Eurocentric terms that not all global societies have used or would have used, they felt that it would be appropriate as placeholders for the time being in the absence of any direct cultural data. Again, how nice would that be to have?
Hmm.
The second big surprise was that the grave sites demarcated individuals who were closely related to each other. So
Hmm.
sons were buried with their fathers, for example. And the third big surprise was that the lineages appear to have been patrilineal and patrilocal. Now, just to define these terms, a patrilineage is when descent is traced through the male line, and a patrilocal or virilocal residence is when a new wife goes to live with her husband's family and community. So, in just one observation, a pedigree A is connected to another lineage by one woman who must have moved into her husband's family, which included a brother, two other men, and her sons. And the same seems to hold for the majority of the other adult women in the grave site, who have no recognizable ancestors among the graves. The strontium isotopic data adds further clarification to this, showing that each of the women sampled were born and grew up in different areas before coming to stay with this community. And this arrangement would be defined as exogenous by anthropologists. And of course, you can find parallels to this with a great variety of recent human cultures in the ethnographic record. Now, at the head of pedigree A is a man and his wife, who are one of the oldest people in this community. And his grave is rather curious because his burial is not accompanied by grave goods to signify any ancestral status. And his remains were a pile of rather jumbled long bones compared to most everyone else. Now, unfortunately, his wife was one of the few individuals that could not have their DNA sequences, so um, we can't really answer whether she too came from an outside community, but one could reason that she may also have come from elsewhere. Now, the confusing mass of the husband's bones suggested to the team that he was reburied, or his remains were retransferred from another site, although more data would have to be obtained to clarify that situation. Now, one interesting finding was that the majority of children in the graves were younger than 15 or 8 years old,
Hmm.
and at either age, they seem to have been buried with specific goods. And that kind of gives hints that maybe these ages were important social transitions for the community, which may have been associated with coming of age ceremonies. Again,
Hmm.
this is a common feature in many societies around the world and throughout time. But you won't find any half siblings here. The genetic data only uncovered children with direct adult ancestors. And that tells us that this Neolithic community, at least, practiced monogamous pair bonding,
Hmm.
in contrast to some other sites at the time that show evidence of polygamy. So,
Hmm.
like, there's one site where one man had children with four women. So, further research of this sort will need to be done to show whether monogamous or polygamous relationships, which one was more common or not, and whether these were impacted by social status, as has also been seen in the ethnographic record. But across the grave sites here, there seemed to have been no correlation between the way that a body was buried and their relationship or status in the family. But given that there was little to no overlap in the graves um, between individuals and because the individuals were related to each other, the authors proposed that the grave site might actually have been visibly marked on the surface, kind of like a modern cemetery,
Hmm.
which would suggest that individuals not only recognized where their relatives or their ancestors were buried, but probably also how they were all locally related to each other. Now, that might seem like common sense today, like, knowing who your ancestors were, at least your immediate ancestors. But it certainly helps, I think, in our understanding that prehistoric peoples were, far more like us living today than we tend to imagine or tends to be portrayed
Hmm.
in popular media. That's always important.
Hmm.
What is also seemingly modern for this Neolithic site is the quality of health among the population. In some cases, the genetics showed that some families had up to six children, who then went on to marry and then have four or five children of their own. And the isotopic data shows very little in terms of low nutrition or poor health. Now, such reproductive success and the survival of these offspring are only possible if the community was able to feed and care for each other. Therefore, the team argued that this community had a very high fertility rate and low death rates for the young, where health conditions remained stable and nutrition through farmed and hunted goods, as was the case at the time, was generally pretty good.
Hmm.
Um, Now, of course, social factors could have played into maintaining this good run. Humans are good cooperative breeders, so that seems to be a general model for early human societies that the care for children was shared among members of the community, particularly mothers and grandmothers, for example. But of course, these speculations must remain just that for now. Now, the final surprising thing from the Gurgi site was this relatively short period of occupation. The isotopic and radiocarbon dates show that these 7 generations only lived on this site for only a few decades. So the earliest ancestors of this community moved here, possibly leaving families behind, as evidenced by the lack of parents in the earlier generations, and settled for an estimated 84 to 112 years. Now, if you factor a generation as living 28 years, that would mean that the last 3 or 4 generations actually grew up at Gurgi. Now, the team looked at earlier linear pottery culture sites for which we have more architectural remains and found that the average longhouse, which was the typical dwelling at the time in Europe, only lasted about 20 to 30 years, 70 to 100 if it's maintained very well. So, if the people built similar structures here, they may have also kept up the health of their homes as well as their bodies for at least a little while. So then the question begs, what happened in the end? Why did everybody seemingly leave this place? Now, the authors do have this to say, quote, an alternative or complementary explanation for a limited occupation time could be the depletion of local soils and other natural resources, driven by non sustainable agricultural practices that could have taken different forms, which is still a subject of intense debate.
Hmm.
And indeed, that is the case. We discussed this a little bit in Humanity of Prologue in some of the later episodes. Um, but there does seem to be some evidence to suggest that deforestation practices, for example, were occurring earlier during Europe's Neolithic period than has usually been argued. Usually, those dates are pushed to like medieval times.
Hmm.
And that would have affected how and where farmers lived and worked, particularly in how the felling of trees would have impacted the river quality and then the subsequent soil quality on the land as well. Again, those ecological connections run deep. So
Mm.
perhaps the sense of this community, are buried somewhere else nearby,
Hmm.
and we have yet to identify and connect them through further ADNA analysis. Um, Honestly, I mean, just to kind of wrap things up here, given the pace that the field has been moving along, we've been covering a lot of exciting discoveries in ancient DNA. I mean, we talked about the 2 million-year-old site in Greenland, where they were able to get environmental DNA to recreate
Right.
an entire ecosystem that the fossil record would have only given a partial image of. Um, I could easily see a situation in the near distant future where you could have a reasonably incomplete but growing ancestor descendant map of places like Neolithic Europe uh, that could be constructed, where you see how these different families over millennia were related to each other and moved around. And that would certainly reveal a far more intimate story of human interactions in history than we ever thought was possible. And goodness knows, imagine what discoveries could come from that. Um, and so that's kind of what I had to say about this paper. I'm really excited about these sort of landmark discoveries in ancient DNA, and I'm always excited when the next one comes around. But I'd love to hear both of y'all's thoughts about this.
Go ahead.
Yeah, so I mean, ancient DNA has always been, I'll say always, like since I've known about it at least, one of those topics that's like it's always mind-boggling
Mm-hmm.
to like the level of detail that you can, sort of resolve from these. Um,
Yeah.
and it's not even the thing is like a lot of these things you'd think are sort of obvious, right? But I guess it's more so just like the fact that all these things can be deduced specifically from these lines of evidence that I think is the most interesting part.
Mm-hmm.
Um, so yeah, I always like hearing about these sorts of things, even though, like I said, I don't necessarily follow paleoanthropology or anthropology in general as closely as, I probably should. But um, yeah, these sort of things are really cool to just be able to flesh out these sorts of patterns and relationships. Um, do we know which neighboring communities, or I guess have they been named? Like what other communities were practicing, um, say polygamy, for example, in or nearby them, and were they like temporally contemporaneous?
Um, I would have to get the names from those from the paper because I do believe they name dropped that one that I mentioned with the man with four wives,
Mm,
or I guess however that that would have been viewed. Now, in terms of like connecting through ancient DNA, I don't believe we have that just yet. Um, but there's certainly plenty of sites during this passive phenomenon that I think reasonably could be connected to this Gurgi site, um, because this was an archaeological site that was just a cemetery essentially.
Mm.
It seems that wherever the whatever happened to like the place where the people lived themselves, the longhouses if they built those, does not seem to have been found yet. Um, but given how extensive Europe has been kind of cleared out as far as archaeological sites are concerned, I wouldn't be surprised if something like that was found um, in the near future, or if it has been found already, it just hasn't been given this treatment.
right.
Because I believe this site, the excavation's only been within the last decade or two,
Hmm.
something along those lines. But that would be my guess.
Right. Yeah. I mean, my main like reason for wondering that sort of thing is just, partly the wants to sort of put a name to, different groups of people that are moving around, but also just it also just ties into, again, this notion that we can find so much diversity in how people are living based on these genetic studies. Like even stuff that's been inferred based on like, I think, different Neanderthal cultures maybe versus the Homo sapiens, depending on how you split that, that were living uh, in the same sort of regions at least, if not the same time, or if not the same time as them. Um, because what was it? I think some combination of hybrids. I was listening to a story. It might have been you guys covering it
Hmm.
a little while ago about sort of inferring, you know, were wives going to live with their husbands or were husbands going to live with the wife's family, and they were looking at it based on somebody who had both Neanderthal and Homo sapien DNA,
Mm.
and I think they'd been found with a group of other people. Um, and I don't remember if they were able to sex them per se, but I remember there being some inferences being thrown around about, Neanderthal societies live this way versus, the contemporary quote unquote Cro-Magnon societies. And I know that's an old throwback term, but they were living in this sort of fashion. And yeah, it's just cool to see that balance, or not balance, but that sort of those interactions and how they actually, um, crossed over in different ways. Um, very compare contrast sort of thing.
Yeah,
So
that's
much
very
just yeah, human
interesting.
diversity.
Because I don't know if I'm familiar with that paper per se. If it was a recent one, I do know that there has been some discussion about admixture between Neanderthals and Homo sapiens, and yeah, you'd be right. Like that's the whole other discourse as well about whether Neanderthals should be considered Homo sapiens or not. Just that's a whole thing I could get into. Um, but I have heard that there seems to be a trend in a lot of the ancient DNA that they've gotten showing the admixture events with Neanderthals, particularly following the into Eurasia exodus about 70 to 50,000 years ago or so. And it seems that the general trend that they've been able to detect just based upon the presence of like the Y chromosome, for example, is that Neanderthal men would typically take Homo sapiens wives, and it was through those interactions that sort of the more um, fertile offspring were derived. And it's something along the lines of like the daughters may have been more fertile than the sons, something along those lines, um, which is an interesting pattern, and that would suggest that maybe there was some sort of patrilocal thing going on with at least some Neanderthal groups in that part of the world where maybe Homo sapiens women went to live with Neanderthal families, whatever that would mean. Because obviously there's a lot of extrapolation about societal relationships that you could get into about whether these admixture events were, um, for lack of a better word, consensual or not. That's certainly a topic that could be discussed. This probably has been. Um, but it's interesting that you mentioned that because, like in Neolithic Europe, a similar thing does seem to have happened. We know that forager or hunter-gatherer societies in Europe go back a long way. The Cro-Magnons that you mentioned, the early European Homo sapiens. I guess that's the technical term now. And there's all kinds of subcultures to that. The Maoric Nation, for example, they had kind of the run of the place for many thousands of years, um, and it's until about 9,000 years ago or so that these agricultural groups are coming in from the Anatolian region, where some of the earliest agriculture was produced in the world. Um, and it's not until about 7,200 years ago that they started making incursions into Western Europe, which is where, there would have been contact between these earlier hunter gatherer groups and these incoming farmers. And while it does seem that in some parts of the world, hunter gatherers picked up farming practices it does seem like there was sort of like a huge fusion of societies going on, because until sort of the last of the major incursions in Europe, about 5,000 years ago or so, with the Indo-European speaking peoples, the Naya cultures from Central Asia, the majority of ancestry in Europe, I think like 90%, was those Neolithic farmers. So that
Hmm.
hunter-gatherer component was reduced or is just gone altogether across much of that glorified peninsula.
Hmm.
So um, I imagine like these sorts of studies would go a long way into really clarifying how those hunter-gatherer groups interacted with these farming communities, and whether it was the same picture all over the place, or whether it
Right.
varied over the couple thousand years that the Neolithic emerged on the European stage. Um, so that's a very good question, Ade. Um, hopefully, that's something that we could talk about in the future. Um, is there any more questions, Alp?
I guess I don't have too much to add that either you haven't covered already. Um, but I definitely agree with both of you. This is an incredible study. Like the fact that we can get this amount of detail through ancient DNA is definitely quite something. I do remember seeing this paper come out because it came out in Nature actually. Um,
Yeah.
and yeah, I remember looking through the Nature articles. Out of habit, I do check every week when Nature prints just to see if there's anything relevant to my field of study. And of course, this isn't quite within that range. But when I saw the title, I said, "Oh yeah, Joan would like this." And having heard you describe what it's all about, I could definitely see why this made it into Nature. And as is often the case with these kinds of landmark studies, I think they also serve as a sort of useful case study, perhaps. Like if we can do this, if we can figure all of this out with this particular site, you know, could we apply similar methods to get similar amounts of information out of sites of similar age? That certainly seems to open the door to that kind of possibility. Definitely something to look forward to see how future studies kind of make use of similar lines of evidence or build on top of this.
Oh yeah, and certainly I'm sure there could be applications to other aspects of paleontology.
Mm-hmm.
If we want to understand like sort of the like if we find what would be a good example? I don't know, maybe like a mastodon community
Right.
out
Hmm.
in the American Southwest. If they're all buried together, you could find out about what their relationships were like to
Yeah.
each other. I mean, obviously elephants don't. Well, I don't want to say that. Elephants might not have pedigrees in the same way that we do, but obviously their social connections run deep.
Right.
So it would be interesting to see kind of how extinct proboscideans and elephants as well would have kind of lived together, right? Like,
Mm-hmm.
Hmm.
were mammoths and mastodons and gomphotheres engaging in the sorts of complex, um, sort of like herding behaviors with a matriarch, and migratory behaviors that we see in African and Asian elephants today.
Yeah.
That would be really
Right.
cool to find out. Yeah, goodness knows I was excited about this. It's funny you mentioned like, yeah, Joan would like this paper. I think on the Discord when I posted the link, I think I literally said, "Holy shit, we can actually do that!" With all caps. So, yeah, I just eat all this stuff up. And like I sympathize completely, Ade, about paleoanthropology just being a huge field where a lot of research has come out. I mean, trying to keep up with like the flow of research that's been coming in, and not just the research itself, but like the debates and the discourse and
Right.
the interpretations and reinterpretations, because um you know the field of paleoanthropology, and I'll extend that to human prehistory as well, since this technically covers that. I know sort of this later period of Homo sapiens is not usually considered paleoanthropology, but like it definitely has connections there.
Right.
Um, um, there has been major shifts in the last couple of decades in terms of how we approach these topics, because I guess much like paleontology, like maybe dinosaur paleontology, for example, to follow your example regarding the dinosaur renaissance, um, we've had a lot of these like long held notions about human origins and evolution that have just stayed in the field for decades, even long after those earlier anthropologists and researchers had kind of begun to chip away at them.
Mm.
And even now, there are these arguments regarding the life ways of ancient hunter gatherers and other peoples, um, and how diverse they may have been compared to what they've been originally proposed. You might be familiar with the man the hunter model,
Hmm.
um, which is where this idea that social organization in early humans, even going back to say Homo erectus, where you had males going out and providing all of the resources for the family, while the females stayed at home and just kind of reared offspring and like tended to things. Right? That's a very
Right.
1950s American family approach to
Right.
looking at human social organization. But the people who are coming up with these ideas, that probably said more about societal attitudes at the time than the actual remains and peoples that they were talking about. And so there's been a huge pushback from many different researchers, not just feminist archaeologists, mind you, but all over ethnologists,
Mm.
who have been trying to, take cues from the vast living canvas of human cultural diversity in contemporary time to show that, hey, listen, you know, there's probably a lot more going on with these ancient peoples than we could even imagine. Life ways that we have never observed in the ethnographic record, and so we should be very careful about pushing these preconceived notions of like our current cultures today back into the past, because we might be way off the mark in terms of how these peoples were actually living. Um,
Right.
Even something as simple as like stone tools, right? We're so used to thinking of stone tools as like kind of the be it all end all for like technological evolution among hominins, right? Like we follow these tool technologies and they seem to tell us everything we need to know about, okay, here's hominins getting more intelligent and more complex. When in actuality, if you look at, what ethnographers and archaeologists have seen with more contemporary hunter-gatherer cultures, or at least those that continue to practice these life ways,
Mm.
the use of stone for tools is a very small part of their overall toolkit. I mean, all kinds of organic materials, ropes and plants and animal bones, um, you know, a lot of those don't readily preserve in the
Right.
archaeological record. And so when we look at these stone tools and we're just focusing on that, we're probably only seeing maybe 5-10% of that whole picture. Um, and so now we're getting speculations and possible evidence that is probably pushing some of these technologies even further back in time and are really changing how we view some very old hominins. Like I think right now there's one discussion about how Homo habilis may have been using like sling bags made of plant materials that they
Hmm.
could like hold materials or even infants in, which would certainly correlate with the kind of loss in hair thickness that has
Right.
been observed in hominins, where okay, these babies don't have anything to cling on to anymore. How are they carrying infants around? And oh gosh, I'm rambling a little bit, but like there's just a whole world, and you'd be very forgiven for trying to take it all in at once when there's just so much going on. It's part of why I love it. It really opens your eyes to kind of like what we're capable of and what we can do as a species, and there's more than one way to being human,
Yeah.
essentially.
Yeah. That example you gave just now, like with the sling bags, it immediately brought to mind like at least in various African cultures, and that carried over to some extent to Afro-Caribbean, Afro-American cultures. The not pap, it's not a papoose per se, but like that same sort of wrap your baby up in a blanket and just keep it on your back.
Yeah.
Like that's just it's something you don't think about as being like you know I don't know. It just it certainly brings like just another level of sort of dimensionality to like even other species of people. Like, oh, this is a method that's been going on maybe for a long time. And like the example I'm thinking of that I am aware of, like the current, I guess, argument, and I'm sure this is a whole conversation or series of conversations unto themselves.
Sure.
The what is it? The Naledi Cave, I think, in South Africa.
Yeah.
Oh yes,
That
yeah.
big debate right now. I don't know what's going on with that. I know it's being talked about, so I'm aware there's a discussion being had about whether they could or were either burying people there or like had fire to lead them down there or something. There's a lot of stuff going on, I think.
Right. No, we definitely plan to talk about that when the next update special comes around. So I guess if you want like our full story on that, like, stay tuned. But yeah, basically the long and short of it is, a group of paleoanthropologists stumble across more research in this Dinaledi cave chamber with Homo naledi, um, and based on their observations and initial excavations, they're seeing a lot of things that they believe is evidence of like complex ritual burials, um, pictographic images on the walls, yeah, use of fire, more, I guess, more complex behavioral repertoires than is expected for a hominin with a cranial capacity on par with Australopiths and chimpanzees.
Hmm.
Um, and they've gone ahead and basically published these findings and speculations before they actually did all of the work to confirm whether that actually was the case.
Hmm.
So they kind of they ran ahead before seeing the finish line, and the whole paleoanthropological community has responded in kind, but not necessarily always kind. So, um, yeah, it's been a whole mess. I mean, goodness knows, I would like for it to be true, but I mean, you gotta put in the work first,
Right.
before you go, stating these things and then having a huge media campaign, including books and a Netflix documentary.
Yeah.
Oh my gosh, because yeah, goodness knows in paleontology that wouldn't fly, let alone paleoanthropology. But like there certainly is an important conversation to be had relating to that. I mean, I certainly don't deny that earlier hominins, besides I guess more derived Homo like Homo sapiens, could have been capable of, I guess, more of a complex cultural repertoire than we usually give them credit for. I mean, even among chimpanzees today, among our closest living relatives, I mean, within that species, there are multiple different cultural variants among
Right.
them that have kind of given us hints into how maybe these sorts of early hominin cultures could have differed from each other. Um, and so when it comes to like even like something like fire, just to throw that for example, um, the whole discourse about like making and using fire, like there are multiple ways to utilize fire as a resource that does not just involve rubbing two sticks together or striking a rock and creating a flame.
Mm.
We know that chimpanzees, for example, will observe wildfires closely, and as kind of the flames pass by an area, then they'll go in and they'll pick up all the burnt animals and plants and eat those. um, so like that is technically like a use of fire. It's just chimps are not doing a quest for fire kind of thing, right? Where they make a flame and it's like they hold it. It's a completely different way of understanding fire use.
Right.
And so I mean, if chimpanzees can do that, then it almost certainly seems reasonable that other hominins, especially very early ones like the Australopiths, could have done that, um, and maybe taken it maybe in a few different directions. Because of course the question about Homo naledi fire is, okay, well, how do they get the fire? Did they make
Mm.
it from elsewhere? Did they take it from wildfires? Is there something else going on? Those are questions that should be answered. But unfortunately, in that case, even though like they had argued that they had found evidence of fire and put that out there in news reports, they haven't published on it yet.
Mm.
Those three preprints that they dropped that were then reviewed with eLife's very weird new peer review system that I'm sure that's another conversation. Um,
Mhm.
None of those at all mentioned the fire use at all. So it's like, okay, what happened there? Like you make these big claims about fire and then you just don't publish on them. Like, what are you waiting for? Um, of course, what I would like to wait for is like the actual work to be done,
Right.
because yeah, it's kind of frustrating too because like I mean, Homo naledi in and of itself, like this, the whole story of the Rising Star Cave expeditions, like that's already fascinating enough. Like it's a
Yeah.
remarkable sight that people were able to squeeze through those chambers to get to those remains, and find so many hominin fossils. Like I think the Denali chamber is among the most like remain dense finds for a hominin, comparable to like Cimo de los Huesos in Spain, where there's just so many bodies there that you can have a little bit more confidence in making inferences about morphological diversity among ages and sexes, for example, than we're usually privy to. Because I mean, some hominin species are only known from like one remains,
Right.
so it's like you can't really go beyond to speculate social behaviors and that sort of thing from just that. Um, and so I feel like a lot of this discourse has kind of lost sight of the importance of these remains, like in and of themselves. Um, yeah, just it's just been kind of an unfortunate situation all around. I'm sure ask me again a year from now, and things would have probably changed by then. Maybe some of the work would actually have been done, um, because I do imagine that like the burger team behind those remains, um, they kind of wanted to get it out as soon as possible to get conversations going and to kind of guide their research, which that seemed to be like a legitimate cause on their part. Like, listen, we're not used to working with these sorts of remains, or at least most of the team is. How should we go forward with this? Um,
Hmm.
because there's like that method of publishing where you just kind of get it out there before you do all of the work. Then there's the approach where you take like 15 years on like
Hmm.
one set of bones, which is what happened with Ardipithecus rhamidus with Tim White's team in Ethiopia, where they initially published like in the 90s, um, on a few of the remains. Like, oh hey, we found something that maybe it's an Australopith, maybe not. We're gonna call it Ardipithecus rhamidus, and it's pretty old. It's like the oldest hominin that we have right now. And then they just kind of hid like that complete skeleton that they had found, and they just meticulously worked on this. Like they got primatologists, they got like sedimentologists, and they went and they did head to toe complete comparative analysis, morphometrics. They threw everything they could at those remains, and then in a series of papers, I think like they took up like a whole issue of Nature and
Hmm.
published all of these different papers on just those specimens. Then they had more of a solid case when they came out and said, "Hey, this is one of the earliest hominins that we've found. It shows, a mosaic of traits. It's not like a chimp. It's not like a human. This could be very big for understanding early hominins." And then they had a little bit more leeway to say these things because they actually put the work into it, um, before publishing. So there's kind of a two ends of a spectrum kind of thing going on here between Naledi and say what the Arty team put through. Um, I know the Michel Brunet, who published a Sahelanthropus chidensis, which is the oldest hominin that has been named about 7 million years. Um, he has been sitting on these fossils for a long time, and he won't say it, but I'm pretty sure he's doing the exact same thing that the Tim White team did with Artie. Like, he published the skull in like 2001, um, and they are just doing everything that they can, and they probably have more fossils than they've actually published. And so maybe in the next few years, we're going to get a big smack dab in Nature again. Sahelanthropus, new studies and all that. Um, and so like I tend to sympathize with that sort of level of paleoanthropology more, just because like they're actually doing research. But understandable that some people don't want to wait 15 years to see a new fossil.
Right.
Um, and so like I kind of understand where Berger and colleagues are coming from, but at the same time, I think they were very irresponsible. They I think they should have waited to at least do some of the initial work and then publish on it, because I mean, some of those tests, like testing um, whether the fire was naturally made or not, like that could be done relatively quickly, apparently. Um, so like they could have waited a little bit, but they wanted to time it with the book and the special. So there's a whole thing with that. Um, yeah, paleoanthropology. It's fun if you can get through all of the weedy stuff. But I certainly love it. Um, but yeah, unless there's anything else y'all wanted to add, I do believe that that's it for our episode today. Ade, listen, it has been really great to have you on. I'm glad you reached out to us, and I'm glad we were able to include you on and share your knowledge and expertise on paleontology. You're wonderful to listen to, and we're happy to support you in your work.
Of course, thank you for having me. Thank you again, and hopefully everyone who's listening has enjoyed as usual, and hopefully I've been able to add some new value to your regularly scheduled programming.
I've certainly appreciated it. And how about you tell our listeners where they can find you?
Yeah, sure. So you can find me on currently most of the platforms. So I'm definitely on Twitter at Adasaur1. I'm also, well, I have a Facebook for the channel as well. Also Adasaur. Um, I have an Instagram as well, which is also Adasaur, but I believe it's Adasaur17 because I think one was taken. Um, but I mean, the most consistent place to find me, or most reliably, is just to find my YouTube channel, which is Adasaur. Um, it's the red, black, and green themed dinosaur logo, which was actually a little a redesign of a photo I took
Oh.
of a piece of tissue paper that I ripped up. That just happened. Literally, I held up to the light because my dad was watching TV at night, and I just ripped a piece of tissue paper and held up to the light and saw that it looked like a dinosaur head. So initially, that was my profile photo,
Right.
and then I modified it to make it look, like the current version does today with a little Pan-African theme to it.
Yeah.
And yeah, I don't know. It's all a bit of a misnomer. I might figure something out later, but I feel kind of wedded to this whole
Yeah.
this whole imagery of it now. So,
Oh, it's really
but
cool.
yeah, that's where you can find me.
Well, that's excellent. Yeah, and we'll definitely be sure to share all of those links so that people can find you and follow your work as well. Um, yeah, this has been great. So it'd be kind of fun to see if we continue this sort of idea, this internews model, where we bring somebody on and they help us with our news episodes because I certainly had a blast with it, and I think it was very helpful in kind of sharing more widely the fields that we're interested in natural history. Um, Now, speaking of interviews, we do have one kind of new announcement. It's kind of funny how like the timing of this worked, but next week, from the time of this recording, mind you, we are going to be interviewing one of our dearest friends, paleontologist Meg Dixon, the heir behind A Dinosaur a Day, which is a Tumblr
Ooh.
blog, which was kind of a project, an ongoing encyclopedia to describe every genus of dinosaur
Mhm.
known,
Yep.
including the avian ones.
Yep.
It was a massive project, many years in the making, well beloved by the online paleo community. So we're going to be interviewing them next week, um, and that will probably be August 17th. I think it actually seems more concrete now. Um, but if any of you have any questions you would like to ask them, please send them in. Of course, we'll give you the appropriate links here in a moment if we move on to our usual kind of closing material. So we are on Patreon. So that's patreon.com/timeandclades, where for any monetary donation, your contributions would help us continue the series and develop new projects and expansions. We've recently kind of reshaped how we use Patreon, so we get more like exclusive behind the scenes content that's shared, kind of early previews of episodes that we're going to be doing, including this one. And so there's different tiers that you could follow. Um, all of our current patrons are on a specific tier where they are owed shout outs. We want to give a big hug and kiss to Paul, Denver, Frankish, and Val Denunzio. So thank you all for your support. Now moving on to our general acknowledgments. Of course, we want to thank our good friends Henry and Alicia for their contributions to this series. Henry is responsible for the music that opens up our episodes, and Alicia is responsible for the color scheme of Albert's Alvarezsaur avatar, which is a cheerful little fellow. Now, of course, we are also on Twitter. We are at Time and Clades. Yeah, even though Twitter's kind of on the wayside, but like, we're going to be there till the ship sinks. So you can find us there. But most likely you are watching us on our YouTube page through Time and Clade. So if you want to like and subscribe, that's always appreciated. If you have any questions about the show, whether about the material that we've covered or just anything in general, you can contact us in 3 ways. You can shoot us an email, timeandclades@gmail.com, or you can send us a tweet, or you can comment on our YouTube page. We will see all of them and we will get to them as soon as we can. Now, if you want to read any of the papers that we've covered on this news episode today, or, for example, visit Ade's social medias, you can head to the description for links where we post all of our references as well as our general descriptions for the episode content. And with that, that's about it. In terms of what we got going on next, well, of course, we have the interview with Meg. That's our biggest priority. I am working on the update special for Humanity a Prologue. That is moving along slowly. Tentative release date towards the end of August, beginning of September, about that time, to coincide with our 3-year anniversary. But otherwise, you can stay tuned and wait for our monthly news episodes that we do every so often, and whatever special interests that we have that we want to share with you all. But with that, that's it for the show. We want to thank you all for joining us. And from all of us, Albert and Ade, we wish you all a very pleasant day.
Take care.
Yep. Stay safe.